Brother, anybody could tell me like what's the updated time, or is it 8:30?
No, it's 8:30, 8:30. I'm just starting. I'm just waiting for everyone to just join in.
I'm so sorry, sir. Actually, I have logged in from phone, and prior 2 days,
No
I have
issues. Actually, I was
quit a
waiting.
job, so I didn't got time, sir.
No issues.
Okay.
Hello, everyone. Good evening. Welcome back to another session. So I think we can start. I see lesser number of students today. I'm expecting students are fasting, so that's the reason. Okay, that's fine. Okay, I think we can start. So we can continue from where we left off. So yesterday we discussed about 2D arrays. We discussed about strings. We saw like basic start of string, what string is, how it looks like, what it's in terms of memory. So let's today try to complete this. So I guess we have completed 2D arrays question. Only one question was remaining to be discussed, which was spiral traversal. Yes. Let me pin this. Okay. Now, since I have lesser people today, I'm not sure of. Acha. Did you all try the spiral order traversal? Is there anyone who is having doubts on that? Shall you have doubts? Clear? Completed? How many of you tried completed? How many have doubts?
Hello, sir.
Yes.
Sir, two questions on spiral matrix, sir, but one is solved and another is not solved.
Okay, spiral matrix 2. Okay, so that's the just reverse of it. Okay, so we did maxima minima, we did find a way, both of these are done. Let's just go to directly this. Let's complete this questions from here, and then we can revision of Pascal's triangle. Okay, chalo, we'll do that. We also have a lot of things on strings to cover. Today is Wednesday, right? Today is Wednesday. So we have Thursday, Friday, 2 days for sorting. Okay, I guess we'll be done. Okay, we have time. Okay. Okay. So let test case. I guess there is a test case error. Yes, I also remember there was a test case which was giving erroneous result.
Sir, yes, sir. That because
Like I guess
पहला जैसे सॉल्व किया था सर, ये भी वैसे ही सॉल्व करने की कोशिश किया लेकिन हुआ नहीं सर.
I guess there is a test case issue. So we'll
Ah.
validate that for 17. Yes, I remember something like that. So that I remember last time also this happened. There was a test case. So I had informed the team. ठीक है, चलो I'll check it again. Is it resolved or not? ठीक है. Apart from the spiral, any other doubts? So diagonal traversal. Diagonal traversal. Do you need solutions? Okay, I'll do one of the diagonal traversal. Tell me which one you want. There is, I guess, top leads is also diagonal. We have our diagonal traversal of matrix this as well. Which one you want? Sum of upper and lower triangle. This is also, I guess. This is like diagonal, but this is similar to that. So let's do this one. Okay? Diagonal traversal equal to the one. It will give you idea of what toplets is. This is the exact diagonal traversal. Toplets is the same thing, right? Toplets is, I guess, it is also a diagonal order. You have to find out some sum or something that you have to print. So if it's true if the matrix is toplet or toplet diagonal from top left to bottom right has the same element. Same. So here you have to just check for the elements. Each element in the diagonal should be same. If it is, then it's toplets. If it is not same, then it's not a toplets matrix. Okay, that's it. Chalo, let's check on this one. So let's do this one. That will give you an idea of how you can do any other diagonal questions, right? Okay, see, so what we have to do over here is we have to traverse the matrix in the diagonal fashion, right? So what did I tell you till now about diagonals? That there is some relation that's going to be there for each diagonal, right? Diagonals will be following some relations, and okay. Now you just need to figure that relation out. Once you got the relation, you have the solution. So for example, let's consider the larger one, right? Let's consider this larger matrix. Here what we are doing is, okay. So here what we are doing is we have like this is first diagonal, this is second diagonal, this is the third diagonal, this is the fourth diagonal, this is the fifth diagonal. And this is the value that you see 3, 2, 6, 1, 4, 1, 5, 9, 4, 8, 7. Right. So these are the values that we are seeing, and this is printed in the diagonal format. Now let's figure out, let's try to write this matrix in terms of indexes so that we can see the values of the index. This is 0, 0, 0, 1, 0, 2. This is 1, 0, 1, 1, 1, 2, and this is 2, 0, 2, 1, 2, 2. Okay. Now here, look at this value. So this is like 0, 2. So, okay, what is this diagonal? This is 0, 1, and it's changing to 1, 2. Okay. This is 0, 0, 1, 1, 2, 2. Okay. This is 1, 0, 2, 1, and this is 2, 0. Let's look for this one. So here it is basically, let's look for any value. Do you see any relation that is getting followed in all these diagonals? There is one relation. Anyone seeing that relation? Yes, that's correct, Adnan. Okay. The relation would be something like I plus j would be something, I minus j would be something, and that's going to be fixed for the entire diagonal. We just need to figure that relation out. Okay. Now let's see over here. So what's the relation? So if it is I, and let's say this is I and this is j. So if you do I minus j, what's the value that you're getting over here? -2. If you do I minus j over here, what's the value you're getting? You're getting -1. If you do I minus j, what's the value you're getting over here? 0. What's the value that you're getting over here? I minus j is equals to 1. What's the value over here? I minus j is equals to 2. So the diagonal starting from top left to the bottom right, the values is changing from -2 to +2. Yes. Or I can say if there is, let's say, if the number of columns is, m or any particular m, so your values is changing from m minus 1 minus of m minus 1 to plus m minus 1. These are the values. So check here. So for example, here how many columns you have? You have 3. So your values are changing from minus of m minus 1, which is this, which is -2 to +2. Okay. And it would be valid for n cross it would be valid for any n cross m matrix. This is going to hold true, right? If it is like not a square matrix, even if it is a rectangular matrix, this condition is going to hold true. Okay. Now let's just so now since we know this, we have the matrix. So okay, here it is given that it is a square matrix, so that makes our lives even easier, right? So this is a square matrix, so we don't have to even worry about n and m. Okay. So okay, our values, we are given n, so the value is going to vary from -n minus 1 to n minus 2. Okay. So what we need to do, how many diagonals will we have? Do you remember the number of diagonals? How many diagonals do we have? ऐसा कुछ होता था n plus n minus 1, n plus m minus 1, right? This is the total number of diagonals we have. Calculate for any matrix here. How many diagonals we are getting? 1, 2, 3, 4, 5. We have 5 diagonals. That is 3 plus 3 minus 1. So in case of like n and m, right? When it is n and m, when it is n cross m, it is just the number of diagonals is n plus m minus 1. Okay. That is going to be given. In any rectangular matrix, if this is not given, we'll be able to find that. All right. A dot length is your n, and a of 0 dot length is equals to your m, right? So we know this value. So now we can find out the diagonals. We can do this, right? Okay. Now let's just quickly run through this. Now if we run the loop for L times, we do I plus plus, and then we have for and okay. Let's call it as row of 0, row is less than n, row plus plus. Okay, we'll run a loop for column. Now what we have to check if the row index minus column index is equal to a particular value. Now what's the value that we want to start with? Let's call it as p, which is initially n minus 1. Okay, which is a negative n minus 1, right? We'll start with basically a negative n minus 1, and then we'll go to positive n minus 1. So we'll check whether it is a negative n minus 1 p. If yes, if that is equal to p, then this is the current diagonal. Like after every iteration, after we are done traversing any diagonal, so this is where we'll be done traversing that diagonal, we can do a p plus plus. So the next diagonal is right now. If we'll start from like minus something, -2, then we'll go to -1, -3, and so on. We don't need actually nested loop right now. I'm writing just a solution. We'll optimize it. Okay, this is not the most optimized code. We can write it in n square. I'll come to that part. Okay, let's first complete this one. Okay. Now at the end, what do we need to return? We need to return just an array list, right? So we need a single array list of type integer. Okay, integer, let's say a, which is equals to, or let's call it as result, right? Result is equals to new array list integer. Done. Okay. And at the end, we can just do result dot add, and we can keep on adding a of row and column. So this is the current result, right? So first so for the first time when this nested loop will run, basically we are traversing the matrix. So the first time when we are traversing the matrix, only this value will satisfy the condition and no other value will satisfy the condition. So only 3 will get pushed into the result. ठीक है. Now when I is equals to 1, for the second diagonal, like for I equals to 1, this diagonal will only satisfy the condition. So we'll just push 2 and 6 into the result, right? So now for the third time, when we'll run for it for the third time, this diagonal will only satisfy, we'll push 1, 5, 9 into the result, and so on. Okay. So next iteration, this will only satisfy, so we'll just push 4 and 8 into the result, and finally we'll just push 7, and this is the result that we'll get. Okay. Now let's just try to return it and see if it is working as expected. Right, so we can return the result, and then we can copy it from here and we can paste it over here. Need to run the code. Why p plus plus c? Now this is working fine. Why have we done p plus plus c? Let me repeat the logic again. See, what we are doing is, firstly we ran a loop that is running for the number of diagonals. Let me run it from 1. Right, so let's run it from 1 to L. Okay, so this is running for the number of diagonals we have. So how many diagonals do we have? The number of diagonals is n plus m minus 1, or in this case, when it is a square matrix, it is n plus n minus 1. Okay, everyone understood this part? How many number of diagonals we have? It is n plus n minus 1. Okay, that is the number of diagonals that we have. Okay, now this is the first part. What's next? So we'll run a loop for the number of diagonals. We'll try to figure out which are the values that is there in the current diagonal. So which diagonal are we looking for, right? So this is like a row and column is this, right? Row and column are just this iterators, right? For the loop, we have declared row and column. This is the row index is changing from 0 to n. The column index is changing from 0 to n. And what we are checking is if that index, if the row index minus column index is equals to p. So initially, let me do a quick try run that you'll be easily able to understand this. So n is 3, right? So how many diagonals will we get? So L will get is 3 plus 3 minus 1, so which is 6 minus 1, which is 5. Okay. Next, what we'll get is p. So p is 3 minus 1, that is 2, and we have a minus 2. So it is minus 2. Okay. Now we are checking for how many times this I loop is going to run. I is going to run from 1 to 5. What we are doing over here, we are starting with row 0 going till n, column 0 going till n. Basically, we are doing a matrix traversal. We are traversing through the entire matrix, and what we are checking? We are checking if the row index minus column index, if the row index minus column index at any point is equals to minus 2. If it satisfies this, then I'll push it into the result. Which particular index will satisfy this condition? Only one index in the entire matrix will satisfy this condition. No other index is going to satisfy. Look at this. There is no other index that satisfies this condition. Why minus 2? See, because the first difference that you have over here is going to be I minus j is equals to I minus j, and here it is coming out to be minus 2. The last difference that you get over here is I minus j, which is 2. So your difference in the matrix is going to vary from minus 2 to plus 2. For this diagonal, what's the difference? I minus j is equals to minus 1. Then this is having 0, then this is having 1, and this is having 2. So you're increasing from minus 2 to minus 1 to 0 to 1 to 2. Understood? How we are changing this? So starting from minus 2, then changing to minus 1, then 0, then 1, and then 2 finally.
So then it should be greater than minus 2 now.
It won't
Not-
be greater than, like the difference is exactly equal to, right? Difference to equally hai, right? So see, first time when this logic runs, see, so for I equals to 1, what we are doing, just look at it. Okay, I equals to 1, what we are doing, forget about everything else. Okay, so these are the values that we got for L and P. Okay, check for I equals to 1 kya kar rahe. Let me do a try in detail. Okay, I equals to 1. We are starting with row 0, row equals to 0. For row equals to 0, I'm going to all the columns. So changing column from 0. So row 0 minus row 0. 0 minus 0, is it equals to minus 2? No. Okay, we change column to 1. 0 minus 1, is it equals? No. We change the column to 2. 0 minus 2, is it equal? Yes, this is equal to minus 2. What's the value at A of 0 2? It is 3. So we push the 3 into the result. This is the first value that we are pushing into the result, which is 3, which is the same as result. Okay. Now next time loop runs, we got the row value as 1. Okay. Now again, we start with column 0. Now for 1, when we'll start with 0, we'll do 1 minus 0. It is not minus 2. 1 minus 1, it is also not minus 2. And 1 minus 2, this is also not minus 2. So none of them satisfies the condition. So we basically don't ever push anything into this. Okay. Then we again go to the next iteration, which is r equals to 2. Here again we do 2 minus 0 not equals to minus 2, 2 minus 1 not equals to minus 2, 2 minus 2 not equals to minus 2. So they are not equals to minus 2. None of them are equals to minus 2. Okay. What else? Okay, so they are not equals to minus 2. So we'll go to this loop are done. Now we'll go to I equals to 2. For I equals to 2, again we'll start, but this time we have increased the p value. So p is no more minus 2, it is changed to minus 1. So now we'll check whether there is any particular difference which is equals to minus 1, not minus 2. So now for r equals to 0, we'll check column 0. 0 minus 0 is not minus 2. 0 minus 1 is not minus 2. Sorry, 0 minus 1 is minus 1. Sorry, we are checking for minus 1, right? So 0 minus 1 is minus 1. So this is the index that satisfies this condition, 0 minus 1. So what is the a of 0, 1? So that is 2. We push 2 into the result, which is this. Okay. Next, we change the column to 2. We check is 0 minus 2, is it minus 1? No. So we don't do anything. We then go and finally update the row index. Okay. We change the row index. Row index changes from 0 to 1. Now would we do 1 minus 0 not equals to minus 1. 1 minus 1 not equals to minus 1. 1 minus 2. Yes, this is equals to minus 1. So once minus 2 is it is equals to minus 1 to push this into the result. So what is a of 1, 2? Say of 1, 2 is this value 6. So which we have pushed into the result. Understood? Now see, what we are doing is whichever element is satisfying the diagonal condition, we're just putting that into our result. Okay. For e, and we are starting with minus 2. So firstly, the first diagonal that we wanted to put into the result was minus 2. First diagonal, then second diagonal which we wanted to put into the result was minus 1, and then 0, and then 1, and then 2, and so on. Okay. Clear? Understood? Now this is it. This is the solution. This is not optimized. This is n cube. Okay, we know that. But this is okay. Will it get accepted? Let's check. Well, so we might see TLE, right, which will optimize. Okay, it's passed. Right, it's fine. Now, see. So understood everyone this solution? No one has any doubts on this? Then I can proceed to optimizing this. So this is n cube, right? Given the constants 500, this is going to work, right? Because n is 500. So we might even work for 10 cube. That is fine. But there is an optimal solution than this. Okay. We can do this in optimal. What's the space complexity? There is a space complexity which is order n square, because we are storing all the elements over here. So it is n square, right? So this is also storing n square, and the initial matrix was also storing n square. So total amount of space is n square. Any additional amount of space that we have used is also n square. No, even if you break it into two separate operations, upper and lower diagonals, then also it is going to be n cube, right? N square additional space. So the space complexity is n square. The time complexity is n cube. Okay. This is n square loop, right? This is n square. This is pretty straightforward. 0 to n, 0 to n. Okay. This is n square loop. This is like this outer loop is running for 2n times around, right? 2n minus 1, or we can say 2n times. So it is 2n cube, or in order of n cube. Okay. Now what do I always tell? Understood why it is n cube and why the space complexity is n square. Okay. Now, what do I always tell you? How do you optimize things? You optimize things by looking at the innermost loop, right? Whatever operation innermost loop is doing, that is having the most chance of getting optimized. That's the place where you should start thinking. So now what's the innermost loop is doing? So it is finding out the matrix. So finding out that diagonal. So we know that we have to print the first diagonal, which whose difference of a of I minus j is equals to minus 1. Is there anything that we can observe from this that we can utilize instead of running these two loops? So what is wasting time over here? So the time is getting wasted because, for example, let's say we want to print this diagonal, which is having only one element. What I'm doing is I am traversing the entire matrix, which is not required. Right? Is there any way I can just traverse this diagonal which I want to print? is there any way I can just traverse the diagonal I want to print, not the entire matrix? No break, but so there was someone who observed. ठीक है, चलो Adnan, that's a great observation. ठीक है. So how is the row and column index varying in any diagonal? Just look at any diagonal and tell me how is the row index and column index varying. This diagonal or this diagonal, how is the row index and column index changing? If I just want to visit those diagonals, I need to traverse through them, right? I don't need to traverse through the entire matrix. How is it varying? It is changing by row +1 and column +1. So let's say if we start with 0, 0, the next value is, next cell in this particular diagonal is 1, 1. If I start with, let's say 0, 1, the next value is 1, 2, right? So row index increases by 1, column index increases by 1. If I start with 1, 0 and 2, 1, so like the row index and column index both are increasing by 1, right? Achha. So we just, let's do this. If I just give you the initial row and column values, okay? If you just know the initial row and column values, will you be able to traverse through this and print the like diagonals instead of going through the entire matrix? We can just start from some initial row and column and we can follow this approach. Yes? No? Do I not make sense here? Do I make sense? So let's do this code, right? That will make it easier to look. It's very easy, right? The code is very easy. Let me just copy this solution once so that I don't lose context of it. Let me paste it over here. So where I have written spiral matrices. So let me do a diagonal traversal here. So it is diagonal traversal. Okay, this is first solution, which is NQ, and now we are optimizing it. So let's see what we can do. So see, always the innermost loops takes most of the time, so we can simply remove them. We don't need them. Okay, we don't even need a P, I guess. Okay, so let's check. So what's the row? So we don't even need this. So we have these many number of diagonals. What we need to do over here is, for each diagonal, we'll have some row index, some initial row index, and then some initial column index. There would be some initial row index and some initial column index. Okay.
Sorry to interrupt you, sir.
Yes.
एक्चुअली सर 2 दिन से मैंने क्लास नहीं लिया सर, तो मुझे समझ में नहीं आ रहा ज्यादा कुछ. आप 1 मिनट में हिंदी में बस क्वेश्चन समझा देंगे तो मैं थोड़ा कनेक्ट कर पाऊंगा.
अच्छा.
आई ट्राई लाइक आई एम.
Okay,
1 मिनट लगेगा जस्ट सर.
हाँ, ठीक है. See, so what we are doing here is, so what is this question about? So this is telling that earlier we like a few days ago when we were learning about 2D matrix, there we saw that there is a concept of diagonal. What is diagonal in a matrix is basically any right, anything, right? Now in this question it is told that there can be a lot of diagonal. This is like just not the left to right or such diagonal. So this is like the ideal diagonals that we know, right? But any other diagonals can also be possibly exist in the matrix, which can be, for example, this is also a valid diagonal. ये भी एक valid diagonal है, ये भी एक valid diagonal है. ठीक है, so ये सारे valid diagonals हैं. ठीक है, length vary करता है, but they are again in the diagonal format. Same left to right हो सकता है. अभी इस question में क्या बोला गया specifically कि we have to traverse all the diagonals and print their values in the order. So for example, यहाँ पे हम इस diagonal से start करते हैं. So पहली value जो हमें मिल गई 3. Next we see 2 and 6, so we print 2, 6. Next we 6, 1, 5, 9, so we are printing 1, 5, 9. Okay, same order में.
जी sir.
And then this. So finally we have to traverse all the diagonals and तो जो सबसे पहला सॉल्यूशन हमने लिखा उसमें क्या करा है, कुछ दिमाग नहीं लगा है कि एक रिलेशन फाइंड आउट करा है कि डायगोनल क्या रिलेशन है सारे डायगोनल्स के बीच में। तो वेरी करता है कि अगर रो माइनस कॉलम करेंगे हम सारे डायगोनल्स के लिए, सो पहले हमें मिलता है -2 देन -1 देन 0 देन 1 एंड देन 2। ठीक है, तो ये -n-1 से वेरी करके +n-1 तक वेरी करता है। सो हमने कुछ नहीं करा, हमने बोला कि कितने डायगोनल्स है टोटल, ये तो हमें पता है n+n-1, ये हमने फॉर्मूला फाइंड आउट करा था। ठीक है, कि हमारे पास टोटल इतने डायगोनल्स होते हैं, सॉरी हाँ, सो हमारे पास टोटल इतने डायगोनल्स होते हैं, हम उसको ट्रावर्स करेंगे एंड देन हम हर एक डायगोनल के लिए हम फाइंड आउट करेंगे इस डायगोनल में कौन सी वैल्यू है। ठीक है, कौन इस कंडीशन को सेटिस्फाई कर रहा है, तो रो माइनस कॉलम किसके लिए -2 हो रहा है, फिर वो उसको हम रिजल्ट में ऐड करें। फिर नेक्स्ट विल अगेन ट्रावर्स, विल चेक for which row minus column is -1, we'll just put it into result, then we'll check for row minus column which is 0, we'll put it into result। ठीक है, अंडरस्टूड, थोड़ा सा आइडिया लगा कि क्या कर रहे हैं। नाउ दिस इज नॉट ऑप्टिमल, ये n क्यूब है, अब इसी को हम ऑप्टिमाइज करने की कोशिश कर रहे हैं कि हाउ कैन वी ऑप्टिमाइज दिस फ्रॉम n क्यूब टू n स्क्वायर विच इज लाइक अ बेटर सॉल्यूशन। ठीक है,
जी सर, थैंक यू।
ओके, तो हाँ हमने फिर रिमेंबर दिस फार्मूला, टेल मी ये किसको याद है, सब भूल गए इसको, नहीं याद है किसी को भी, ये कैसे आया था, याद है?
मेरे न्यू है सर ये, आपने बोला मैं याद ही कर लूंगा, मुझे क्या समझ में नहीं आया सर। n+-1 आई एम वेरी फ्रैंक सर इन आस्किंग क्वेश्चंस।
नहीं ये ठीक है, दिस एवरीवन फॉरगेट्स, नो वरीज। सी दिस इज नॉट अ फार्मूला, दिस इज बाय ऑब्जर्वेशन। ठीक है, वी डिराइव्ड इट बाय ऑब्जर्वेशन। ऐसे देखो, सी लेट्स से दिस इज द मैट्रिक्स। ठीक है, माय सिंपल क्वेश्चन इज कि हाउ विल यू सी, आई नेवर टेल टू रिमेंबर फॉर्मूलाज बिकॉज यू विल फॉरगेट देम, ट्राई टू ऑब्जर्व इट, ट्राई टू फाइंड इट। ठीक है, चलो लेट्स टेक अ थोड़ा सा ऑड साइज मैट्रिक्स लेते हैं। ठीक है, 1 3 2 3। ठीक है, now let's look how many diagonals we have. So let's say if we are asked to, we are given any n cross m matrix, we don't even know what is the formula of total number of diagonals, we have to figure out. ठीक है, हमें बताना what is the total number of diagonals that this n cross n matrix is going to have. Okay, so let's check. So this is one diagonal, this is one diagonal, this is one diagonal, this is one diagonal. Okay, what do we observe about these diagonals? कुछ तो observation कर सकते हैं। So one observation that I am seeing is, so the number of columns we have, right? So this matrix has 4 columns. So you have 4 diagonals in the upper half of the matrix. See, for column 0 there is one diagonal, column 1 there is another diagonal, column 2 there is another diagonal, column 3 there is another diagonal. If I just introduce a new column, will it have one more diagonal? Let's say 2 4. So this okay, this would be, yeah, this would go over here, this diagonal will extend over here, and this is one new diagonal. So now we are having 5 diagonals, right? So this here the number of diagonals is equal to the number of columns. So let's say this is an n cross m matrix. So how many diagonals we have? So here we have m diagonals. Okay, m diagonals ऐसे मिल जाएंगे at the top half of the matrix, which is equal to the number of columns. ठीक है, how many other diagonals do you have apart from this? So apart from this you have 1 and 2 diagonals. What is this? So जितने rows होंगे, for them also you are starting one diagonal. So for example row 0 row 1 के लिए you are starting 1. If there was one more row, will you have one more diagonal? Yes, if there was one more row, we will have one more diagonal. This will part of this diagonal, this will be part of this diagonal, but this will be a new diagonal. So जितने rows होंगे उतने new diagonals start हो रहे इधर से. That many new diagonals are over here. But just that this is this we have already counted, right? So we don't need to count this again. So leaving this aside, we have n-1 diagonal. So total number of n plus m minus 1 diagonals. If it is n cross n, so the m is equal to n, so it is n plus n minus 1 diagonals.
नहीं नहीं सर, ये जैसे आपने बताया कि अगर हमने कॉलम से देखा तो ठीक है सर, m डायगोनल्स हैं। अगर हमने रोज से देखा तो सर रोज पे भी उतने बन रहे हैं ना सर,
रोज पे बनते, बट इसको हमने काउंट कर लिया ऑलरेडी, राइट? इसको 2 बार काउंट नहीं करेंगे, इसको हमने कॉलम के टाइम पे काउंट कर लिया है। ठीक है, सो इस वाले डायगोनल को हमने कॉलम के केस में काउंट करा, तो रो के केस में काउंट नहीं करेंगे, रो के केस में जो रिमेनिंग है उसको काउंट करेंगे। एक कॉमन, राइट?
ठीक है, डन सर।
So this is like the formula for finding out the diagonal. I don't even know it, I didn't even remember it. I figured it out with discussing with students only. इसको ऐसे कर सकते हैं। See, most of the time there is no formula as such, ऐसा कोई formula नहीं that you cannot figure out. It is by observation every time. Because if you just observe it carefully, you will be able to figure out what is some general. Just try to apply this logic on some n cross m, like 3 cross 4, 2 cross 5, 3 cross 5, and you'll get the result. Okay, so now here we have like some small problem that, okay, so let's say these are the diagonals. We want to know the start value, and then we want to know the like starting of row and column. Okay, so the first row and column is, so row is going to start by 0 for the first m diagonals. Column is going to decrease by so let's do it, let's break this into two parts. Okay, so let's first print the m diagonals, that is these m diagonals, which is going to have row index is always starting by 0, and the column index is starting by some m, right, which we can say is so let's say if it is m is going to be 5 in this case, m5, so it is starting with m minus 1, m minus I. Okay, we can say it m minus I. So see, here it is starting with m minus 1, m minus 2, m minus 3, m minus 4, m minus 5. Okay, so starting with 4, m minus 1 is 4, m minus 2 is 3, m minus 3 is 2, m minus 2 is m minus 4, like 4 is 1, and so on, right? Okay. Now, if I look at this, so what else we need to do? So while the row is okay, so now we want to just traverse this diagonal. Until when we'll traverse? While the row is less than n and column is less than m. Okay, if this condition satisfies, row is less than n, column is less than m. If this satisfies, then we'll keep on traversing, and until like if it doesn't satisfy, then we'll stop then and there. Okay, now every time we have the result, so every time we'll traverse. So for example, when we start with this, we'll get this result. We just need to add this into let's say a of row and column. No, this is m, and both of them needs to be true. Both of them needs to be true. Row index should also be valid. Column index should also be valid. If any one of them is not valid, then we'll just stop. Achha, both are n. Okay, here both of them are n. Okay, so here it changes. Okay, so both of them are n, so we can write everything in. That's fine. Thanks for pointing that out. Once we add this, we need to increase the row by 1, column by 1. So that's how this diagonal is there, right? So for any diagonal, just say, okay, if we start with 0, 2, what's the next value? So row changes to 1, column changes to 3. So row and column increases by 1. What's the next value? Row and column increases by 1. That's it. Okay. So this is the first m diagonals. And for the next m diagonals, you can either write in a different loop, or you can write it by handling it over here. Both of them are fine. Then we are remaining with n minus 1 diagonals, that is here. Now the column index is basically fixed, which is starting by 0. And the row index is now varying from 1 to something. So we can start with I. Right? Row index is varying by I. That's it. So you are starting with 0, 1, 0, then you are starting with 2, 0, then you are starting with 3, 0. The number of rows you have, this is going to run for that many times. Okay. Now if I run this, we would still see the same output. Should see, right? We should at least see this. Okay, now we see the same output. Just that now the complexity has reduced. See, so now this operation is order n. This for loop, and this while loop operation is also order n. Now why it has reduced from n squared to n? Because earlier, in order to figure that diagonal out, I was traversing the entire matrix and I was telling that these are the elements which were part of the diagonal, right? Okay, see, earlier what we were doing is just let's compare these two logic. Okay, so the previous logic tha, how were we trying to tell, how we are trying to figure out which is a diagonal, which elements lie on the current diagonal. So in order to figure the elements on the diagonal out, what I was doing is I was traversing the entire matrix. The pure matrix pe ja raha tha, even though there can be only one element in the diagonal, even though matrix has only even though the diagonal has only one element, even though the diagonal has only two elements, I am going through the entire matrix to figure out which two elements or which one element lies on the diagonal. Right? So here that's what we were doing using these two row and column. And this was n square complexity, but at the end we were only getting 2, 3, 4 values, those which were lying on the diagonal, that were satisfying the SIP condition. Okay, now this is fine, but we observed something else which is better than this. What did we observe? That in case of any diagonal, if we just know the starting row and column index and we just increase the row and column index by 1, that would be like to whatever values it would increase, it would be the next values in the diagonal. So we can traverse the diagonal. So now what we are doing is, when I want to like add this diagonal, let's say 0, 2, 1, 3, 2, 4 into my result, I don't need to traverse the entire matrix and figure these three elements out. What I'm doing is I'm just starting from 0, 2, then I'm changing to 1, 3, and then I'm changing to 2, 4. I'm telling these are the elements in the diagonal. Done. See, so that's what we are doing. We're starting from a row and column index. We are updating it, and this will just traverse on that diagonal. Okay. So the outer loop is order n. Inner loop is also order n. In the worst case, we are starting from some 0, 0, and we're starting till some n. So this is also order n. Okay. So this is n square, and this loop is n square. So 2n square is similar to n square. Okay. Optimization. Okay, so let me explain the optimization wala part. While condition. Okay. Okay. Submitted. See. Optimization mein what I always told you about how to optimize is think through the innermost loop. Innermost loop is the place where you should start thinking. Okay, because 90% of the times the innermost loops consume the time, and this is where you can easily optimize. Okay, this is the thing that you can easily optimize. Okay. Space is n square. Space is still n square because we are using a new result, right, which is storing the entire matrix. So this is storing the entire matrix, so which is n square. So space is n square, but the time has reduced. Space remains same, but the time has reduced from n cube to n square. Okay. See. So here the duplicate operation, this would definitely have duplicate operation. If there is no duplicate operation, then you have written the like most optimal logic, right? If there is no duplicate operation, or there is no such operation that you can do in lesser amount of time, then you have already the optimal solution. Here, is there any operation? Yes. If let's say I am on a particular matrix, so let's say I am on any matrix in this. So when I am traversing through these values, when I am traversing through this 0, 2, 1, 3, 2, 4, what is happening? Look at this. Let me just use another pen. So when I'm traversing through this value, what is happening is I am actually getting only 3 values in the result. But here I am telling the entire matrix, I'll go through this row, I'll get 0, 2. I'll go through this row, I'll get 1, 3. I'll go through this row, I'll get 2, 4. Then I'll go to this row, I'll get nothing. So I'll say, oh, these are the 3 values that lie in the diagonal. This is what we are doing over here. Okay. Exactly, this is what we are doing over here in this particular logic. Understood? This one. Is this logic clear? Ki what we are doing over here? Now, why this is a problem? This is a problem because we don't need to traverse the entire matrix to get any diagonals. Here, what I am telling is, okay, let me undo this. Okay. Now we still need to get this red diagonal. Okay. Now we still need to get this red part. I'll talk about the space just a second. Okay. Now we still need to get this red part. Now what we are doing is, we know this, if we figure out the start row and column index, that we can do, that we have a way. So for example, the row index for these diagonals is always starting with 0. Like all these diagonals, the row index is always starting with 0, and the column index is varying from, we're starting from 4, then 3, then 2, then 1, and then 0. So we are basically starting with n minus I. Okay. So these relations I told you, right? Always these kind of relations would be n minus I, n minus I minus 1, n plus I, n plus I minus 1, I plus 1, I equals to I, something like that. Okay. So you got the relation is n minus I. Okay. So row is starting from 0, column is starting from n minus I. Now we have to traverse this diagonal. How do we traverse any diagonal? So let's say we got this. Row is 0, column is 3. Okay. For I equals to 2, you'll get column is 3. How? N is equals to 5 in this situation. So I for second traversal of I equals to 2, you're going to do this. N minus I is 5 minus 2 is 3. You'll get column is 3. So now what we are doing is, we are doing row is less than n and column is less than n. If this is true, then we'll keep on doing this operation. So is row less than n? Yes, row is less than 5. Is column less than n? Yes, column is also less than 5. So both of them are less than 5. So we just push this into the result. So we push 0, 3 into the result. Okay. Next, we increase the row by 1 and column by 1. So 1 less than 5, yes. 2, 4 is less than 5, yes. So which is this value? 1, 4. We push this into the result, which is 1, 4. Then we again increase, row changes to 2, column changes to 5. Okay. Row is valid, but column 5 less than 5 is now false. So we don't have any more elements in this diagonal, so we terminate. Now see how much iterations should be required to figure this diagonal out? Only 2 iterations. Only 2 iterations that is a number of elements in this diagonal. Only that many iterations we require to traverse this diagonal. We do not require any more operations to traverse this. Understood? So now we are not doing additional traversals. We are just traversing the diagonal, and that's it. We are getting the diagonal values. You can like, so for like loops, doesn't matter if you are using for loop or if you are using while loop, that is not going to cause any difference, right? So for example, instead of this, if I change it to a for loop, if I take the like move this to here, that is also fine. You can take this two values over here. You can move the increments to there. Okay, this is also fine. If you prefer writing for loop, you can write it. It's just that for more complicated logic, I prefer writing while loop because that looks easier and cleaner to understand. See. Now here you can write it in this way, or you can initialization, you have condition, you have updation, right? Just that row and columns are updating, two variables you are updating. Okay. So instead of doing this, I prefer it writing in this way, looks more cleaner, easy to read. Okay. Why are we increasing row and columns? Because that's how this will get updated, right? We are increasing the row and column in the while loop because that's how this is going to get updated, right? See now, like what is going to happen in this matrix when we are increasing row and column? That's how it is getting updated, right? Row is increasing by one, column is increasing by one, row is increasing by one, column is increasing by one, right? That's how it is getting updated. Okay, understood? Clear? Let me paste this logic, do it. It's ultra optimized. This is like just a plain simple optimization observations, right? See, there are only two things you can think of, right? There is only three things that you will initially it will look like very difficult, but once you master this, you'll observe that there is only three things you have to look. Okay, what's the three thing? The first thing is when you're writing loop, you always would need to see whether the innermost loop is doing some additional work that that can be optimized, right? If the innermost loop is doing some work that you don't need to do again and again. So for example, here we were traversing the entire matrix, and in order to find out a diagonal of 1 or 2, so there is some optimization that we can definitely do. Now, how will we do it? For that, we need some observation. We can observe something, and that's how we'll figure this out. Same goes for the largest and the smallest wala case, right? Yesterday, there we saw that we are doing some operation largest and smallest. So that was the innermost loop. We try to think, can we do this operation in O1 time instead of On? So our complexity will reduce from n cube to n square. And we got a solution. Yes, if we already know that smallest and largest, we can do it. So there we saw that and we did it. Same thing over here, we did it, right? Maximum minimum thing, yes. One question is homework, array question, please solve that. Which question, array question, did I write it over here, right? I have, which array question can you remind? I guess, कुछ तो लिखा था मैंने. I remember, okay, I got it. I wrote it in the functions wala part. No, I wrote it in the, okay, I remember यहाँ पे लिखा था मैंने, I forgot the question. Right. We have to give an array of positive integers. You have to find the sum of, you have to find all such subarrays whose sum is greater than, okay, got it. Anyone got the solution of that question? You're given a subarray, you have to find out the sum of all the subarrays and tell which subarray is greater than, which sums are greater than k. We have to tell the count of that. Using a single for loop, that's great. Okay. So let's do this spiral order. I guess the spiral order 2 hai na, that is like there is a problem in the test case there. So we can't do anything about it. That I'll get the team fix it. So I guess there is a problem in the test case. Apart from that, the logic you are writing, I guess, is fine. Okay. Anyone having doubts in spiral order, normal spiral order traversal, or is it done by everyone now? वो हो गया या you have doubts? Done. Okay, done then. No one is having doubts. Not done. Doubts. Just give me a second. Okay, sorry for that. Sorry for that. Not working. Start strings questions. Okay, how what else are doubts on? So if this is done spiral, chalo, I'll take if there is any remaining doubts in the 2D arrays part now. I guess we need some time today on strings. I guess we need to invest some time. If there is any doubts that's remaining in 2D arrays, okay, that you are still facing, so we'll take that up once let's complete strings. Okay, so I'll revisit this part. If there is any doubts that's remaining or any question that I have given you, right? So try those questions. I remember that I have given that question, right? So something we'll revisit, we'll revise this. I'll solve those questions. Okay. So let's continue with strings because this is something which I want 1.5 hours at least today to do a detailed discussion on this. Okay. We saw it, but I don't want to give you superficial information on string, right? We want to see it on depth. Okay. So let's start with strings and we'll take some time over here. सर ट्रिपलेट्स तो हमने सॉल्व कर लिया है ट्रिपलेट्स तो हमने सॉल्व करा था एरे ट्रिपलेट्स दैट क्वेश्चन वी हैव टू टेक 3 loops and that cannot be optimized right now like that can be optimized like by using dp or hash map which we don't know, right? So that ncube is fine for now.
सर वो एरे लिस्ट था तो वो सिर्फ मतलब जो रिपीट आ रहे थे ना जो एलिमेंट्स वो कैसे काउंट करना है?
ठीक है चलो array list doubts I'll see. ठीक है array list doubts let's complete strings and then I'll take array list doubts.
Okay.
ठीक है okay if you have doubts on okay array list के doubts we have not discussed, right? I expected that would be done. ठीक है चलो we'll do that as well. Okay, so let's start with strings, complete them and then we can have the entire time to take doubts. Okay, so we yesterday saw some idea about string. New string given checks here if there is any hello in the lookup, then it returns the reference to reason behind it, creating string equal to same memory. Okay, so there is like JVM that is it is doing the caching, right? That's what you're telling Shiva. That's fine. That's fine. If you use said asking new space and when string let all returns stored. So that's what it is doing, right? It is doing it is creating a new string, and if it is looking from that constant pool and is doing so that's caching to optimize it. Right, that's fine. Right, every compiler, every memory management system would do some caching to optimize it. But see, so okay, I guess everything else was covered in the same. Only this thing that you are telling is slightly different. So okay, I'll cover that. Okay, see, so what is strings? Strings is a special type, right? String is a special type. So what happens in case of string? How string is special? So string is basically a string has like behaves like a normal variable, like how we know int, float, double, and something, right? Now, should we now switch to VS Code? No, you are fine using this online terminals for now. For any coding thing, you are fine with this, right? You don't need to switch now to VS Code. Like we'll tell you when you should start using it. Okay. So now string behaves like a normal variable, just that it has a little bit more additional capabilities. What additional capabilities? We can use dot length to get the length of the strings. We can that keeps us the number of characters. We can use caret that tells us what is the character that is present at any given index. We can use a loop to traverse to each of it character by character, which we can't do any like in any data structure like integer, float, boolean, double. We can't do that, right? That is not allowed. But here we can do it. Similar to arrays, how we were traversing arrays. So there was a small concept that I explained you yesterday. So where string is not stored in stack, string is not stored in the heap. So where does it get stored? So it is stored in a part of the memory known as string constant. Okay, so it is stored in a part of memory known as string constant pool. Now, as the name suggests, this is a constant memory, right? So strings are treated as constant. Whatever is stored over string here, whatever string you store over here, that is treated as a constant variable. Now, what is a constant? Something that whose value cannot be changed. So, for example, if you do this operation s is equals to hello, this is a constant value kind of assignment. So it creates a hello in the memory, and it puts that hello into this s. Now, if you create, let's say, if you put s is equal, if you again do s is equals to world, what it is going to do, it is not going to update this. It is just going to forget about this memory, create a new memory world, new string which is having the string world, stores it into the existing variables. So the variable now starts pointing to the new reference. This memory gets garbage collected. Okay. So there is no way to update a string, and that's why we say strings are immutable. You cannot update any character at a given index. You cannot Okay. So ठीक है. Shiva, that is the exact caching that I was you like that you're talking about, right? That is the exact caching. ठीक है. So see, so there is okay, that is a caching that every compiler. ठीक है, I'll come to that. ठीक है. So this is what is happening for each of the string variable, right? So when you have string variable, you update it, and new variable gets created, new memory gets created, and that value is getting stored into the string. This is a new string altogether, is nothing as such in the existing string. So due to this reason, we are not even allowed to edit any character in the string. So in case of array, you were allowed to do this, and this was a constant operation. This was a constant operation, updating any value in a given index of array. Now in case of strings, you cannot do it. In case of strings, we cannot update the value at any given index. That we are not allowed to do. We can read the value using caret, but we cannot update it. There is no way to update this value. Okay. Now there is a okay. So this was the small idea about string. Anyone having any doubts in this part? Getting length, storing a value in a string, which is a constant. We are putting it. You update it. New value gets created in the memory. That gets put into the string. Okay. Achha. Now there is a concept of like this is like the normally how you create strings, and then you can create string using this new keyword, right? New string, and let's say hello. Okay. ns2 is equals to new string hello. So every time you use the new keyword, what was the thing that I gave you about new keyword? So new is a keyword that is used to claim memory. Okay. So claim memory. Whenever you use new keyword, it basically always uses a new memory. It never reuses any existing memory, never looks if there is any existing such memory. It always uses a new memory. It always claims a new memory and it uses it. There is no existing memory that this is using. It always would claim a new memory and it would be using that. Okay. So this is what new keyword does, and it's same. So it gets it will still get stored into the string constant pool. String constant pool is a part of heap, right? Remember, this was a part of heap, similar to heap. So this also follows the same dynamic memory allocation thing. So stack was the only thing which was statically allocated. This used to happen on compile time. String and these are like this is just a part of heap. So this is dynamically allocated, or this allocation can happen at the runtime. Okay. So this is part of heap. So similarly, like when you create an array, new array, and you use the new keyword. Why we are using the new keyword? Because we don't know the size. We are just asking the space from the heap section. We might be knowing the size. We might not be knowing the size. We might pass a n. So for all those reasons, we create it on the heap section. Same goes for strings. We create them in the heap section. This is a part of heap. This string constant pool is a part of heap. It is not a part of stack. Okay. Clear? Okay. So this is simple, right? New keyword, new memory gets from string constant pool. Since it is a part of heap, a runtime allocation happens similar to how a heap allocation happens for arrays or any other object type that you'll see later. Okay. String builder I'll come to later. String is like similar to like how we are using this. This is like a easier way to write it. This is like claiming that memory ourselves. ठीक है, यहाँ पे memory claim करते हैं ourselves. We have more control. Here, whatever compiler is doing, right? Whatever compiler's default behavior is, that would follow. ठीक है. तो यहाँ पे compiler क्या करता है? What does compiler do over here and what does compiler do over here? So here we are telling explicitly कि भाई, give me a space where we want to store hello. And I'm telling, give me another space. I want to store the same string. Doesn't matter what you are storing. It will always give you a new space. So this is new space. This is new space, and it will keep on giving you new space as you keep on writing hello in new keyword. So if you use the new keyword again and again, you will get a new space every time. Okay. So every time you use a new keyword, you get a new space from the string constant pool. You store the string. Every time you use a new keyword, you get the new space from the string constant pool. You use that space to store your string. Okay. Clear? न्यू कीवर्ड इज वेरी सिंपल. जब भी न्यू यूज करेंगे हम, नया स्पेस मिलेगा, हम उसमें स्ट्रिंग रख रहे हैं, और हमारा जो वेरिएबल है, ये वेरिएबल तो रेफरेंस टाइप है, राइट? तो ये रेफरेंस टाइप है, उस लॉजिकल एड्रेस को पॉइंट करेगा. ठीक है, हम प्रिंट करेंगे तो हमें स्ट्रिंग के केस में वैल्यू दिखती है, एड्रेस नहीं दिखता. सो इवन दो दिस इज अ रेफरेंस टाइप, दिस स्टोर्स द लॉजिकल एड्रेस, दिस नोज द लॉजिकल एड्रेस, बट इट विल स्टिल बी प्रिंटिंग द वैल्यू. So geeks mentioned it as stored in the heap part from pool. So we're string in term to make it store in pool. Why See, so I don't get the question exactly, Shiva, but I guess you're asking this, right? So basically, if this is a part of heap, right, and this string constant pool is a part of heap, okay? It's a part of heap, just that a special section in heap, okay? Think it like there are only two rooms, okay? There are only two rooms, one is the stack and one is the heap. Within the heap, inside this heap, I have created some small part of this heap I have reserved for strings. Okay, no one else is going to interfere this area. This is only reserved for strings. I will not be storing arrays or objects over here.
So,
Yes.
I mean, it is like, can I annotate and show like what I'm telling you? Like, if we have this as a whole heap, and this is like a string constant pool. So if we use new keyword, it will get stored in this heap, not in this string pool. Because as you said that entire using of string pool is to save memory, to use already created strings to return the reference. But when we use new keyword, it is actually asking for separate memory. So there is no use of a string pool which is created for it. So then it will get stored in heap. And instead of
Okay, I got your point. Okay. Yes, that's fine. Okay. So what you're telling is when we'll use the new keyword, it won't go to the string pool. It will be part of direct heap, not the like the special part of the heap, right? It would be
Yes.
just part of here. The string would lie here, not in here, right? Yes, yes, fine. That's fine. Yeah, that's so that's so new basically puts it into the heap. Now this is like the compiler specific thing where in the heap it is wanting to put it. So ideally, I guess when you are using new, it would put it over here and not use this. But if there is some caching, it might put it over here as well. I think ideally it will put it here. But in some caching, if it is doing, it might use the constant pool similar to the logic that it is doing over here.
Yeah, and one thing, sir. I mean, if we use a string intern method by using new keyword, then even it is asking for new space, it will get
go to the constant pool.
Constant.
That is fine. So there is like way to override it. By default, it will go over here and then you can put it over here if you use that intern keyword, right?
Yes, that I got.
That is fine. Yeah. Okay. See, okay. Let me summarize this. Okay. I know this is enough of like confusion for all of you. See, for simplicity, if you are having doubts, right? Sections, there is so many things. You can remember it in two parts. One is stack, one is heap. Stack contains int, float, boolean, everything. Heap, arrays, strings, everything goes to the heap. In heap, there is a special section on a string constant pool. There are some strings that will go to the string pool. Java does it for like caching, for example. If you create a string hello, okay. So let's say this is one classic example of how string pool is helping us in caching or how it is helping us reduce the memory footprint. So for example, let's say this is the string that we created hello. Now, if you create another string s2 is equals to hello, what Java would do is, since hello is already present in string pool, it will say, you know what, string is already present in string pool. I know this. So let's just s2 points to this string itself. S2 would start pointing to the same reference. So there is only one hello that is there in memory, which is in the string pool. S3 is also pointing to this and S2 is also pointing to this. If you do S equals to S2, since both of them are pointing to the same thing, you get it is equal. You get the reference is equal. Okay. Now, if you update any one of them, now if that string is not present, it will create a new memory, it will update it. Because if let's say you updated S2 to world, so S2 will get updated, S is still pointing to hello, it is valid. It will not get garbage collected because there is one reference pointing to it. See, if there is the memory, there is any reference that is pointing to it, it won't get garbage collected because we for compiler, we are using it. If we have pointed a reference to it, we are using it. If we don't point any reference to that memory, it will get garbage collected because we are not using that reference inside. We don't have any reference to that memory inside code. So might not be using it. Yeah.
So we will try to print after, like, if we have initialized this S2 to hello, and if we'll try to print S1, so it will all like it will print hello itself.
S will be hello, S2 will be world, right? Only S2 will get updated.
No, in the scenario like where we have given both string as the same hello, and if like after some time if you want to use that variable S1, so it will the value will be stored there.
I did not get the question. So basically, you have one string hello, and the second string is also having hello. right?
Hmm.
So there was only one hello that was there in memory. If you have done it via this, if you use new keyword, then both of them have their own memory that is different, even though you store the
And
same.
after in the code, in the same code, at some instance, we want that S1 for some operation. So can we access that?
If that memory is, if you have used it, if you have a reference to it, you can use it. If you have not any, you don't have any reference, that will get garbage collected, so you cannot use it. So for example, let's say let me write this, right? So for example, let's say we have S and then we have a S2. Okay, so this is also equals to hello. So now actually both of them are the same string. Okay, because Java will do some optimization, caching, it won't create two strings and it will just use the same string over here. If I print system.out.print println S, and then okay, let's do it. Press S2 and I run this. So both of them are hello right now, right? Both of them are pointing to the same thing. Now if I just update S2, now it would create a new memory which is storing the world. S2 will start pointing to that. S is pointing to hello, so that is fine. There is a reference that is pointing to hello and it won't get garbage collected. Both of them are now different, right? S is hello, S2 is world. No, so when we updated S2, S did not get updated because both of them were different references, and like if we ever update S2, it will just create a new string. Okay, if it doesn't already exist.
Got it, sir.
Got it. Okay. See, so string doesn't go to string. String goes to the string constant pool using this. If we use this, which is like most of the cases we'll use this approach to put
Hello, sir.
value to string, it will always go to a string constant pool, right?
Hello.
Yes.
Sir, in this case, is when S2 is initialized to world, then where the memory is stored in string constant pool or heap?
String constant pool. So this kind of initialization is always in string constant pool. So if you do
But-
else equals to something, it always goes to string constant pool. Okay.
When you use new keyword, then it is stored in the heap.
Heap, right? In new keyword, it is stored in heap, but there is ways to like move it to the string constant pool. One way is to use entry keyword, and then there are other ways as well by using which you can move it to the string constant pool. Okay, so like most of the time, it would always try to put it into string constant pool until we explicitly specify. So which was one example is this: we are explicitly specifying use heap. Try to use new keyword, you get heap section of memory. Okay, that will store it in the heap section. Okay. Okay, can we see one example using heap new keyword? Yes, I saw it. So let me use that existing. Yeah, so this is a example. So here what we have done is we have created two strings. Both of them store hello. Both of them are two different memories. They are both storing hello. So now if I update S2 like something to, let's say, world or something, S2 string is going to now like update it, create a new memory location, store world into it and something. Okay. S2 is same. Okay, there is only one difference that you would see over here, which is in the case of equal to, and like there is no other thing that you would see any difference or anything that is not working. Only this case would be a little bit different. See, so let's say we are comparing them and writing equal and not equal. If we have both of them are using new keyword, so both of them are different memories. Okay, they are different memories. So now if you print it, they print not equal. Okay, why? Because they are different memory. You are claiming new memory every time. So new memory, how can two memories be same, right? Their logical address is different. If you're comparing the references, it would compare the logical address. It is different, so it will say not equal. Okay. Now,
this is the thing, sir, which I was exactly asking, which you told it right now, that
Yeah.
as equals to S2. Okay, thanks.
Okay, and if you do this, you would get equal. Okay, if you do if you do this operation, you would actually see equal, because now it is getting stored in string constant pool, and both of them are actually the same string and they are the same reference. They're pointing to the same thing. So if you do this, you would actually see it is equal. Okay. Here in this case. So this is the entire concept of memory in string. So mostly we will be using strings like this, which will go to the string constant pool. If you do equals, it will always say equal. Instead of this, I gave you an alternate approach, and don't use this double equals to while comparing string, even though it's available. Always use this approach to compare strings, which is s dot equals, or you can check it character by character by traversing it using a loop. Okay. So if you should always check it by this. Now this always compares it by value, no matter however you have taken the string. So if you do this, this would still say you that it is equal, which is comparing it by value. Okay, that is fine. And here also it would say it as equal. You will never require to compare references. That is not required. You always need to compare values. Okay, so in both the cases, it is giving equal, no matter you are using new string or you are using this. Okay, so that's why you should always compare strings using this, not this. Okay, understood. So this was the entire idea of memory that we know, that we understood about strings. Stored in string constant pool, we have two ways to create it. We have one more string buffer that we'll see later. It is treated as constant, so you cannot update it. You cannot add new things into the end. You cannot add new things into the start. You cannot update even a character in the string. So all those operations are not allowed. It is completely immutable. Right? In case of array, it was immutable. That it was, we were not able to add values at the start or end. But here we are not even allowed to update as well. In array, we were allowed to update, but here we are not allowed to even update as well. Okay.
सर एक कंफ्यूजन था
हाँ, yes,
सर जब हमने एक स्ट्रिंग yes करके एक पूरा स्ट्रिंग बनाई और उसके बाद yes कर मतलब उसी वेरिएबल को एक नई वैल्यू असाइन कर दी सपोज हेलो और वर्ड राइट तो ये पॉसिबल है और अगर हमने yes डॉट कैरेट आई करके अगर उसको मतलब नई वैल्यू असाइन कर दी
नहीं,
तो वो भी तो
वो नहीं होगा. So that doesn't work. So for example, this thing, right? So let's say we have a string and we try to do this s dot caret. So this will not be this is not a valid operation. So if you try to do s dot caret 0 is equals to, let's say, a, this would fail. When you run it, it won't allow you to do this.
और सर अगर हमने yes इज इक्वल टू करके s डॉट कैरेट कर दिया तो फिर वो तो एक नई स्ट्रिंग बन जाएगा ना इसकी
हाँ, वो तो नया स्ट्रिंग बन जाएगा, राइट?
तो फिर तब पॉसिबल है, राइट?
So ये तो complete नया string हो गया ना. This is losing the entire string and you are getting one character out of the string और उसको यहाँ assign कर. ये भी actually this is not valid. This is an error because this is a character and you are assigning a character to a string. So ये incompatible type का error देगा. You have to convert that into string. You can do it. Easiest way is string concatenation use कर लेते. If you just add a string, now this will get converted to string and this assignment would be fine.
Okay, मतलब यहाँ पे ELLO नहीं हमें मिलेगा, सिर्फ वो नया मतलब पूरे कंप्लीट नया वेरिएबल में वो ऐसे असाइन होगा.
ऐसे असाइन होगा, राइट? ऐसे में पूरा नया वैल्यू ही असाइन होता है, ट्राई लाइक दैट, राइट? एक नया स्ट्रिंग ही बन रहा है, दैट वी आर गोइंग टू पुट इट. ठीक है,
ओके. और फिर अगर हमने वैसे ही पूरा मतलब लूप ट्रैवर्स करके और सिर्फ ई की वैल्यू छोड़ के ऐसा कुछ किया तो
ठीक. आई एम कमिंग टू दैट पार्ट, राइट? दैट इज द नेक्स्ट थिंग दैट आई वांट टू टॉक अबाउट. ओके, ओके. See, so now my blank it will be H. Actually, I didn't print it, right? So actually I did not print it, so that's why we did not see it. Okay, okay. So this was this, so I did not print it. Let me print it. Yeah. So let me print this. Okay. So now see, S is going to change to simply H, and then this part is hello. Okay, so you see, instead of S, you are seeing simply H because the entire string got erased, and you have just put H into it. See, string mein you cannot update it. There is no way you can update the character in the string. You are basically, I'll explain Himalaya. Don't worry, I'll explain the Pascal triangle at the end. Okay, I'll take that. Don't worry. Okay, if you have doubts, we'll take it. We'll discuss it. Okay. No worries. Just a second. Okay, see, so now we understood this part. We understood all of the things. So now I told a concept about. Okay. So, okay, that's our time talking. So whatever we just discussed, I'll explain in detail. Don't worry, this one. So see, so we understood string immutable. Okay, that is like thumb rule that you can keep in your mind. String is, we will have revision. We have 3 revision sessions after all the like concept is completed. So don't worry, we have revision classes as well. Okay, see. So after like we have created a string that is immutable. Okay, once you create a string, you cannot update it anyway. Whenever you are doing that update operation, you say, sir, I can put a new value into the string. They are telling we cannot update it, but we can put a new string. So I told you about, right? This is creating a new string, storing it into new and storing it back into S. This is not updating the string, right? This is not updating. This is creating a new string and putting into it. This is an order and like this is like it's not actual update in the existing string. You can put it in a like new, which is having more different hello world I write something like this. So this is a new memory. This can be larger string. This can be smaller string. So this is not like previous string. We have changed its length. We have changed its values. It even is a new memory in like the memory part. So it is not the existing string that we updated. We created a new string and we are just using the current reference to point to the new string. Right. So this is not an update operation. हम नया कुछ create करके when we are using the same variable to point to this new thing is not an update. It is basically a creation. It is equivalent to creating something. Okay. So now before going to update part, how can we update or how is it possible? How do we do things like inserting a character at a given index, or how do we update a character at a given index? How can we perform these operations? We'll cover this. For that, you need to understand one thing, right? Basically S is a pointer. Yes. So basically S is a pointer that would point to whatever string you wanted to. You cannot update it in any way, right? Using that pointer, you cannot update it. So let's say if this is the string and we know that this follows the array like thing, so we can get the length, we can traverse through it, we can print it character by character. Can we do other things? So for example, in array, we had a concept of subarray. We can traverse from any given index from I to j, a to b, x to y, right? And we can get that small part of array. We can find out that sum of small part. We can check whether all the numbers in that subarray is prime or not. We can check count the number of even numbers in the subarray and so on, right? Okay, so we can do all these things. Now, can we do the same thing for string? Yes, we can do the same thing for string as well. We can traverse it from a given character to other given character. And what is the use of this? So let's say we want to find out a substring of a string. Okay. How can we print the address? There is no way we can print the address of the string reference. That is always hidden from us. Okay. In case of arrays, we can see it actually, but in case of like we cannot see the address that is stored in string reference. Okay. There might be some functions that is there, but like using this, like how simple it was for array, it's not that simple. Yeah, there might be some functions which can definitely give this, but it's not straightforward. Right? Hash code is not, I guess, what that doesn't give the address, that gives something else. It might be related to hashing it. So I'm not sure if that does it, but there would be some function, but not that if we print s or something on s, we'll get it. Okay. Okay, so now we can get the small part of string and we can print it. So what this logic would do is, so if I run this logic, this is basically finding out a small part of string, which is 0 to 3, which we are getting HEL. Okay. Now what is the complexity of this operation? What's the complexity of this operation? What's the complexity of getting a substring out of string? So if I give you a substring, find out a substring of string of 4. Is it O1? This is O1. Okay. So if I tell it to do it for any k index, k can be from 0 to n. Find out the substring from 0 to k, and k can be something from 0 to n. So it is an order n operation, right? So if we try to do it, k is equals to n, so that is an order n operation, right? So it is an order n operation to find out the substring. Okay. Same goes for this substring function. This is this also does it in an order n operation. Okay. So this is also order n operation. You can either use this substring function that is internally there, or you can write this logic yourself. Okay, you'll need this in a lot of places. So like get used to writing this instead of using the substring function. Okay. Very simple logic, easy. Like we are just taking characters, we are adding it character by character. So first we will add H, then E, and then L will get the character HEL. Okay. If we want to like add it to whatever characters we want, we'll get that substring. Okay. Understood this substring concept? Is this clear? Yeah, how can you get a substring of a string? How can you find out a substring of a any given string? Yes. So now if you got this, did you figure out the solution of these two? I guess few of you even did it yesterday itself, right away. And subtract thing bracket. So there is no, I guess, bracket as square bracket as such over here in string. So there is no parenthesis. Excluding and including. Okay, so this last one is in excluding. This is excluding this character. Okay, so for example, here we are doing 0 to 3, so that is excluding 3, right? It is index 0 to 2, and this is like also excluding this character 3. So for example, in case of this substring function, it takes 0 to 3 and it is excluding this character. It is not including this character, it is excluding this character. Okay, so you would get a substring from 0 to 2. If I want to find out the entire string, so you can need to parse it 0 to n, which is the length of the string. Okay. Okay. Now let's do these two operations quickly, which is very easy, right? Just it's a little bit tricky to think. So let's say we want to insert any character at the given index 3. Okay, you already have a string and you just want to insert a character at the index 3. What you need to do is, okay, how will you find out this? String result is equals to s dot substring. Okay, and we can add okay, what we can add over here, 0 to, let's say, index 3, right? We want to insert the character at index 3, and let's say what's the character that we want to show, let's say r. Okay, and you can again do s dot substring 3 to 3 to, let's say n. So n is in the current situation 0 1 2 3 4. Yes, 5 is the length of the string. Now, if you print this, result, you would see that there is a character r that is inserted in the inserted in the index 3c. So the entire string remains same. The result is the new string that we created. If you want to update the existing current string, you can do that as well. We can basically use the current string. We are inserting a new character in between. Okay, sorry, let me print this. Now tell me, what's the cost of this operation? How much time this operation is taking? How much time this insert operation is taking? Is this a order 1 operation or is it something different? This is a order n operation. This is not O1, this is order n, because substring is a ON function, right? This would run in order n. Right? Even if we implement it ourselves, this would be an order n operation. We need to traverse from 0 to k. Now, can we do this thing without using the substring at all? Yes, we can actually do it. Okay. So what we need to do is, we can take a result which is empty. Okay. We're gonna run a loop from I is equals to 0, I is less than 3, I plus plus. We can do result is equals to result plus s dot caret I. We can add the new character into this result, let's say r, and then we can just do this same thing again, but now we would do it for 3 to s dot length. Okay, finally we got the result that this is the result with the same string with r inserted in the character, r inserted in the index 3. Okay, same logic. See, whatever this function is doing, we have just written the logic ourselves. What we are doing is, we are creating a new string, which is this. Okay, it travels through the k iterations. We just create a new string. We try to append the character. We try to append that character at s, which is, we try to append each character. Right. Now we add this r, and then finally we try to add the remaining part of the string. Now it's the same complexity that you would get over here. It is the same complexity that you are getting over here. Okay, so you are getting the same complexity of that you got earlier. You are getting the same complexity. Okay. One more thing. What's the complexity to perform in the string concatenation? We have not talked about that. You have done it multiple times. What's the complexity to perform this? Let's say you have hello. Okay. And if I do this operation, what's the complexity to do this? What is the complexity to do this operation? So this is a order n operation. This is not a O1 operation. So the number addition was a O1 operation, but in case of string, it is a order n operation. Okay. Finding out like adding a new character to the string is an order n operation. Okay. So this is an order n operation. Now let's say we are doing this n times. So how many order? So is this, what is the like, what's the complexity of this operation? So this is order n. How many times are we doing it? So we are doing it 3 times, and then here again till the length time. So what's the total complexity of this logic? So it is a n square logic to find out, to insert a character into this using substring. Okay, so simply finding out a substring is taking us n square time because of this. String concatenation is order n. We wrote a loop that was order n, but this operation is also itself in order n operation. So the total complexity of substring is n square. Okay, so here, and same goes with the string function. Okay, I'll talk about how it is n square. ये भी n square ही complexity देता है, ठीक है, because of this concatenation. ठीक है, see. So this was a order n operation, right? You all agreed, right? This was a order n, like if I do it till k, this was a order k loop, order n loop, right? If it is running till n, this is a order n operation. Yes? This everyone agreed? Now, of assuming this operation is O1, then its final complexity would be order n. Agree, internal operation was order 1, then the final complexity would be order n. But this internal operation is also not order 1. This internal operation is also an order n operation. Why it is order n operation? Because when you are doing a string concatenation, what is happening is you are copying the current data to a new location, you are adding a character to it, and now this is an order n operation. Similar to as a think as a growth. In case of array list, do you remember what was happening when you were exceeding this? So we are not adding anything over here, right? There is nothing that gets added over here. When you do it plus a, what happens is we create a new memory, we copy all the characters that is over here to this new memory, and then we add a. And this new memory's reference we starts pointing to this new memory. So this is the order n operation. This string concatenation is the order n operation, right? Now, in order to find out substring, you need to perform n string concatenations or k string concatenations. So in order to find out substring, this is order n operation, and you are doing k such operations. K's largest value can be equal to n. So k is varying from 0 to n. So outer loop will be 0 to n, and inner loop will be 0 to n. So in worst case, it is n square operation. Okay, so finding out substring is an n square operation using this logic, right? Using this function is also giving you n square. Okay. So you are running a loop that is order n, but the string concatenation is also an order n operation. String में addition तक order n है. Right? Now this makes string very, very difficult to manage time, because all of your operations will go to n square, n cube, n to the power 4 very quickly, because you are not allowed to insert character. If you want to insert character, that is a n square operation, not even an order n operation. अगर order n भी होता, then it is fine. But this is a n square operation, right? Why adding is order n? Because fundamental, visit the fundamental, right? Look at the memory. What is happening? Are we allowed to add something to the end of the string? Why array list was giving us O1 when we are adding something to the end of this, right? When we are adding something to the end of this, so let's say we have an array list 2, 3, 4, 5. Why it was giving O1? Because it had some additional space, right? So we were just putting the value in that space. But in case of string, there is no additional space to the right or to the left of it. So what we are doing is we are copying the string into a new place, and then we are adding this character. So this copy is order n. This is a ON operation to copy it. Okay, understood? So finding out this substring is n square. Now that makes our life difficult, because we can't do things like inserting a character at a given index without finding out substring, no matter if you write the logic or use the inbuilt substring function. Both of them are going to give you n square complexity. Right, so this is an n square operation. Here also this is an n square operation. This is an order n operation. Okay, fine. This is again an n square operation. So final complexity is n square. Okay, understood? Everyone got it? Why it is an n square operation to add a character at the given index of the string? Even if you use substring, it is going to be n square. Now be very careful while using this substring function, because this is not even an order n function. This is a n square operation. Okay, so be very careful while using this. Okay, while string, okay, but string of a code. हाँ, there I know there is a problem. ठीक है, वो अभी तक fix नहीं हुआ है. ठीक है. So in the terminal there was error that was coming because of string concatenation. There was some memory leak that was there. There is some like would dev part, there is something that is problem in the software itself, and for it's not happening in string concatenation, string buffer, because there is no string concatenation there. It is required. It's not creating new memory. It is using the existing one, so that problem is not happening there. Okay, so let's discuss. Then I'll give you a quick break. We'll discuss those questions. Don't worry, like the terminal questions we'll discuss. Update a character in a string. Okay, update a character in a string. How can we do this now? Think of this. So you already did how to insert a character. Can you think of how we can update a given character? Update कैसे कर सकते हैं? सोचो, update कैसे होगा?
जो भी कैरेक्टर को करना है मतलब 3 की वैल्यू करनी है तो इफ कंडीशन लगा के i इज इक्वल टू जब 3 आएगा तब अपडेट करना है.
Okay, let's say we want to update a character at index 3. So what we can do is we can find out the value still index 2. So this will give us the substring from 0 to 2, which is this. Okay, so 0 1 2 character at index 3 को update करना है. So we'll change it to, let's say, a. Okay, and then the remaining part we'll get this as this. We'll get from 4 to 5. So now we won't get any values of the character 3, that is deleted, and we added a new character in place of it. So now if I print this, see, is it getting updated? See, don't use replace or something. Okay, you have inbuilt function like replace which you can use, but I'll talk about that. Replace actually replaces all such occurrence of it. Okay, it replaces the first. No, it replaces the first occurrence. Right? Okay, that's fine. It replaces first occurrence. But if you want to update any occurrence of it or any given character index, that would be a problem, right? If you want to update at any given index, replace would replace the first occurrence. Replace all will replace the all occurrence. If you want to update any kth occurrence of it, that is a problem. Okay, I'll talk about replace function. Don't worry, right? That I'll talk about. First, tell me this. Understood this? Can we write it without using substring function? So this is the exact same thing that we did over here. यहाँ पे जो करा ना वही कर दिया हमने यहाँ पे. Just that instead of doing this, okay. See, so just that I've just changed this logic from 3 to 4. That's it. So what this is now doing? So what this is doing now is basically it is kind of just skipping one character, that is the character at index 3. We are not adding that to our string, and instead of that character we have added another character which is present at the index 3. Okay, now if you want to delete any character, okay, same logic, just 0 to 3, 4 to 5. You don't need to do this operation, and your character at index 3 is deleted. If you don't add any character for that replacement, so your character at index 3 is deleted, right? So now you can perform an addition, like you can add a character at the end of the string. You can at any index of the string, you can add a character. You can update a character at any given index, and you can even delete a character at any given index. Okay, complexity wise, it is very poor, that because that's how the string is working. So you can't do anything about it. So complexity wise, it is poor, but we are able to do these operations, right? Complexity terms, we have a string builder to improve it, right? So we'll talk about that, how that works, how that is different from string in memory, that we'll talk about. But for now, strings, this is poor, right? This is poor. This thing is a little bit poor, which is the problem. Okay, so we can okay, so now you can basically create string, you can read any string, you can update any string, and you can delete a string. So you are basically, I told you how to do all the 4 operations of the string, like creating, reading, updating, and deleting. Okay, now you can basically perform anything that you want. Complexity wise, you will not get it very optimized, but you will be able to do it. Okay, understood this part? ये समझ आया? नहीं? How we are updating a character? If we use for loop to print the values, will it print the external value, added values? So this value that we have added, so now this is the new string, right? So for example, if I so see, when you do this operation, right? So let's say, so this is when I'm doing this, and I'm printing s. So s is actually getting updated, right? यहाँ पे s actually update हो रहा है, right? It is not just we have just done it here. See, S is actually getting updated. S update ho gaya. So if you use it, you will see the updated value. Same goes for here. If we are just doing it, so result is having the final value, right? If you want to put this final value into the S, you can do S is equals to result. That whatever value you got in result, you will just putting it into S. Okay. See now, so when you print S, it will print the new value, right? That you added with the added character. Convert string into character array you will be able to perform operations, but that is something which you'll not want to do always, because strings is easy to handle. String is easy to pass it. String is easy to so basically string is most of the time is string is call by value, so you would need it like a variable, not in form of array. Array mein jana hai, so that becomes a completely different data structure, that becomes a completely different thing. String is different, right? So that's why string apna use case hai, arrays like characters again its own use case. Just depends what we need. We have character array. If we feel like a character array is giving better complexity, we are the operations we want to do is O1, or we can perform it in a better time complexity using character array, we'll use it, right? But if you want to do things like string concatenation or something, you won't be able to do that there, right? Can we delete the character and string by traversing for loop and do swapping? How will we swap character and string, right? Swapping character and string is like very complicated as simple it is there in array, right? Array mein bahut simple tha. A of I is equals to A of J is equals to temp and something. But in case of string, swapping is not even possible, right? Like it's possible, but it's not that straightforward. We cannot put H into here and O into here. It is a very complicated operation, taking this character out, putting it at the end, taking this character out, putting it at the end. Those two are very big operations. We need to figure this thing out, this part of substring. We need to take this out, this out. If you are asked to swap any middle two values, then that is even more complicated. Okay, so not as straightforward as array. We can do it, but we can use another string to swap it. Yes.
What will be the time complexity for this one that you commented right now? Order of n squared.
Yes, this is n square. Yes, this is
Just
n.
because of that s dot char at operation.
This addition operation. This addition operation is order n, and which we are running for a loop, which will extend to the entire length of string, right? So if you sum this number of iterations that is there in both these loops, so this loop is like total number of iterations is actually equals to n iterations, right? So in each you are doing n iteration, and inside n you are having order n operations. So total is of n square, right?
Okay.
Okay. Can we convert string into array? Yes, we can do it. Array of ASCII we do it actually in some cases where we want to do, or like where we want to do it some optimizations. We actually store it in array of ASCII values, so that we do. Okay. So I'll talk about that. I'll talk about the logic. I'll talk about what all things we can do in strings, how we can swap it. Swap logic I'll talk about today. We'll do that. We'll solve a few questions from your assignments. So assignment questions are easy, right? Assignment question is not requiring any complicated things like this. Okay, so let's take your break quickly, come back, have your dinner, and then we'll continue this discussion. We'll solve a few questions on string as well. Okay, 15 minutes, we'll be fine. Okay, Himalaya, let's I'll take your doubts at the end. All right, okay, so go have your dinner, no worries. I'll take your doubts. If you have doubt on Pascal string, we'll do that. Okay. Is the only reason why strings are useless, because yes, strings are useless only because of this complexity, right? So it is like more of like, if you don't want to perform things like updation of character or something, we use it. But if we require complicated things, we go to string buffer, or we try to go to character arrays or spell, right? Yeah. Okay, have your dinner, come back quickly, we'll continue this discussion. Okay. Hello everyone. Good evening. Welcome back. I hope you all had your dinner. Okay, chalo, let's continue. Okay. Most of the time we use strings. Yes, most of the time we use strings. See, we have so many things, right? String, we have the normal strings, we have string builder, we have character arrays as well. Now, depending on what will give us the best time complexity, we'll use it. We'll start by using string. If we feel like, okay, we are doing too much of these operations where we can use string builder, which will be better complexity, we'll use that. If we feel like, okay, we can use a character array instead of string and string builder, and we'll get a better complexity, we'll use that. Okay, but for now, let's stick to strings and try to find the best complexity we can get using string. The place will not be able to optimize it even further, right? For example, let's say we can't optimize this operation. This is order and operation. We can't do anything about it, right? There is no logic that we can write to change this, right? So there we then will think, is there anything which can do it in O1? Yes, string builder does this operation in O1. Okay, now how it does, how it works, that's a different topic that we'll understand separately. Okay. Let's look at the platform now. So diagonal traversal we did, spiral matrix show, this is error, spiral order you don't have doubts, or if you have, we'll discuss them. So here on string, which questions are doubt over here? String 1, anything? So I told you specifically about this question, compressed string. This is like a very important interview question. This is very, very, very frequently asked in interviews. Even you get this question in senior levels, because this concept has a lot of applications. Okay, the application of this concept is enormous. We use for compression, decompression. We use it for network call. We use it for optimizing query packets. So for example, best example I can give you is this is used in your WhatsApp messages. The same thing, right? So whatever WhatsApp message you send to the other person, it is not sent as normal text. It is firstly compressed into this form, and then it is sent to the other person, and then the other person creates the text that you had sent using from this. Okay. So that's how this that's how useful it is. It is even useful in cryptography or encryption, decryption, all these kind of things. It is used a lot. So a lot of practical implications, right? So this is, so any question that has a lot of practical implication is most likely to be asked in interviews. Okay, done this. How many of you have completed this question? Let me start. Let's solve this one. Okay, so very simple question. Okay, what does this question say? So we have a string, and what we are asked to do is we are asked to create a new string which looks like this. Okay, so what is the difference between this string and this string? So we have to count the number of characters that's given in this string, and if it is, let's say, 3, 4, or 5, what you have to do is we have to replace that. We have to add that character and the count. We have to replace all the remaining characters with the count of that character. Okay, simple. Okay. So for that, what we need to do is we need to traverse the string. If we want to do this, we need to traverse the string. So we can start by here, and we can find out the length. How do we traverse the string? Similar how we can traverse an array. We can start from 0, we can go till n, and we can do I++. Okay. Now we traverse the string. Now what we have to do in each traversal? In each traversal, we have to just find out one character. Okay, that we are going to add to the result. Okay, so let's call this as result. Now there are multiple ways to find out this. I'll write one way that for me looks easy, simple to understand. Okay, see. So what I'll do is, so let's take a count. Okay, let's take a count which is initially 1. Okay, let's take the count inside this. So every time we come over here, we'll assume that the count of this character that we are on currently is 1, right? We have the A of I, its count is 1 because that character we already have, right? The character that we are having already, its count is 1. Simple. Okay. Now we have a character and we know its count, that is 1. So what do we need to do with this character? We need to find out the total consecutive count of it. Now, how can we tell that this character is consecutive? We can check, right? If s dot char at I is equals to the s dot char at I plus 1, then this is the next character is also the same character. So we need to compress this, right? We don't need to put both the characters in the output, so we need to just compress this. So we just can skip this character. We can do I plus plus. See, so now what this is going to do, just check. Okay, forget about the driver code for now. Don't look at there, like what it is doing and how it is reading the string. We'll just try to read use the argument that is given to us in the function. Okay, We have a session that is dedicated for buffer reader and string builders. We will learn that part, don't worry. Okay, see. So what we are doing is, firstly we have A. So we got the character at index 0 is A. We stored that its count is 1. Okay. Now we are checking, is the character at index 0 is equal to the character at index 1. Is it so? So is it equal? No, these two characters A and B are not equal. So what we'll do is we'll not enter this loop, and this loop will never start. We'll just terminate. The base condition itself is not true, so we'll not enter into this loop. Okay. Now outside this loop, we just need to find the result. Now, if the count is equals to 1, then we don't add that number. If the count is equals to 0, then we add the number. So we'll check. If the count is equals to 1, okay, then we just do result is equals to result plus the character that we have. So we simply do s dot char at I, done. And if this is not equals to this, okay, so instead of this we can do this. So if this result is equals to s dot char at I, sorry, if this is equals to 1, we can just add the character. If it is not equals to 1, then we also need to add the count of that character. For example, in case of B, so we'll add the character B, but we'll also add the count of it. Now this thing can be done by easily by string concatenation. So we can use string concatenation to do this. Okay, now let's look now what we are doing. So first iteration we got A, so count is 1. We'll simply do result is equals to result plus character at I, which is A. Done. We don't do anything else, so we not increase I, we don't do anything else. We simply go to the next iteration. Okay, now what's the next iteration? What we are doing? So next iteration I becomes 1. Okay, I became 1. We again got the count is equals to 1. Now this time when we are checking, which is I of s dot char at I, which is B, and is it equal to its next character? Yes, this B and this B is equal. So what we are doing is we are increasing I. So I changes to 2. Okay. Now again we are having this I is 2 and we are comparing 2 and 3. Is it equal? A of I and I plus 1. Is it equal? Yes. So we again increase I becomes 3. Okay. Now we again compare, is A of 3 and A of 4 equal? Now it is not equal. A of 3 is B and A of 4 is C. So A of 3 is B and A of 4 is C. So we are at the last equal index and this is now not equal. We have to increase the counter as well. Sorry, I forgot to increase the count. We have to increase the count. Okay. If you have an entire, we'll do count plus. Okay. So we'll increase the count. So now first iteration when this was equal, so it became 2. Then when it was equal again, it became 3. So since this condition will satisfy 2 times. Firstly, these two are equal, then these two are equal. We started with a count 1, so now it will change it to 2 and then we'll change it to 3. Okay. So final count became 3. And now when we came outside, is the count equals to 1? No, count is not equals to 1. That means we have more than one value. So we'll go to the else part. We'll do a result, which is A of I. So A of s dot char at I is pointing to index 3, which is B. We'll add B and we'll add the count of it. So what's the count of it? The count of it is 3. So we'll add B3. Understood? So basically, if the count is 1, we simply add the character. If the count is not 1, we add the character plus the count of it. So this concatenation is not actually adding anything to the current string. It is creating a new string and putting it. That's why this concatenation operation is order n, right? I told, right? Concatenation is order n because of this reason. If we had additional space and we can put it at the end of the string, then it is like, then it is basically order 1. But here it is order n, right?
Hello.
Yes.
Sir, here is a string, example 1 string. Sir, A triple B double 2 D is there. After the D, if A is there, what can I do?
Okay.
Another A.
So if let's say after D, oh, sorry, what happened? Oh, did I lose the code? Okay, no, I not. Yeah. Okay. See, so what would happen if we have a over here as well, right? So we'll come over here. When we'll come to D, we'll check is we'll store its count as 1. We'll go to check is the consecutive element equal. So we'll store its count as 1. Will A of I equals to I plus 1? No, that is not equal. D is not equals to A, right? So that is not equal. If you have a, this condition will not satisfy. We'll store the count of this as we'll just add D to it. Next iteration of I will increase, we'll come to here and then we'll check. See what
Sir,
this-
what about the last character? Because I+1 is out of bounds, sir.
अच्छा last character ठीक है, oh, so we need to check this. ठीक है, चलो, that's fine, that's a valid concern. ठीक है, so when you have this as the last character, I+1 does not exist, so you have to also check I less than N. Okay, so that would ensure that we are not out of bounds and we are within the limits. Okay, okay, thanks for pointing that out. Okay, now if I run this, we should be able to see this compression.
Sir, I तो less than any होगा, I+1 तो out of bound हो जाएगा.
Oh, yes, I+1.
Let's say in the for loop, it should be, I guess, N-1.
That also you can do, but that won't run for the last character then, right? For the last character, we want to run it because we want to append that character to the end, right? So that we want to do. So yeah, so that's why this is a better choice. Now, if you run this for like N-1, then you might not get that last, you'll not get the last character, right? So in case of this current thing, we won't get D. Right, so that's why the better thing is to run it till N. This would run till N, and we can check it over here. If I+1 is not a valid thing, we won't check this. We can simply proceed forward. Okay, so see, now we are getting D. If I just change it, like put a new character A or something, it will work fine. Okay. Earlier we have got an error as well, which are index out of bound, which was equal to this. Okay. Now if I submit it. Oh yeah, this is like the same problem. So this is a problem with the compiler. Okay, you might be seeing this NZDC thing. So this is a runtime thing. This is happening because of the compiler, not on the logic end. So the logic is correct, but it is a problem with the compiler that it is not able to perform the string concatenations frequently. Okay, so that's why it is failing. If you use string,
Yes, sir, this was happening in other questions also.
Yes, I know this is a problem with the compiler. This is already
All question, this is the same problem, sir.
This is the same problem.
We have to convert in array list, sir, then solve this.
You can do it in array list, but ideally you should be solving it using string. I'll talk about string builder. So there this problem is not coming because in string builder we don't do this concatenation. We have a different way to add characters, so that's why it is not coming there.
Yes,
Yeah,
in character also, array also we can convert. It was not string array.
in character array also, if you do it, it won't say this, but yeah. Okay, this is a compiler issue. This is the entire logic. This logic is fine. This logic is correct. This is a compiler issue that you are seeing over here in NZDC. Okay, which stands for non-zero exit code, which is something which is happening with the compiler while running this code. Okay. Now I have already informed this should have been fixed by now. It has been like a long time I have informed it. Okay, I'll check this why this is not fixed yet. I'll confirm this. I'll start with string builder today. Yes.
Hello, sir.
Yes.
Another thing, sir. What is the error, sir? I pasted in chat, sir. What is this error, sir?
Which error? Okay, so this is basically same kind of same thing. I guess यहाँ पे ना there is some memory leak that has happened, and because of which the process got killed. Is it happening every time you run it?
Yes, sir. Yes, sir.
This was something which I have also seen it. I don't exactly recall. So this is not, again, I don't feel this is a like code error. This is something which is there with the portal, right? That needs to be fixed. Okay, so these errors that you are seeing here, this is not code related thing. This is not something which we are getting. This is like error coming from the portal. If you do this logic somewhere else in some other place, some other portal, you'll see the correct result, right? If you run it on GDB or something, you won't see this error. Okay, so just validate your code first on GDB, and if it's fine, it should be fine, and it is a compiler thing. I'll check this with team now on priority. Wow, when they are fixing this, right? Because this is something which needs to be fixed. Okay. Okay, understood the logic. Apart from this, any doubt on the logic? Anything? Okay, why did we check I+1? See, so for last index, I+1 is not a valid index, right? So for when we are in the index N-1, I+1 doesn't exist, so we'll get index out of bound. To avoid that scenario, we simply checked I+1 should be a valid index, then only we'll do this check. Otherwise, we won't do this check. Okay. Okay. Understood. If this is valid, then only we perform this check. If this is not valid, we don't perform this check. Okay. So this is it. This is the logic. Now, what's the complexity of this logic? What's the time complexity of this logic? Anyone? Any idea? Think through it. What's the time complexity? So this is order n. This operation might go for order n, but it is also increasing I. So this is not causing any additional complexity because we are incrementing the same variable. So let's say if you have all a, this will just reach the end of the array for you, right? End of the string for you, and you're not traversing anything again and again. If you are doing that traversal again and again, it will increase the complexity to n square. But this is not increasing the complexity. Okay. So this is not increasing the complexity to n square. This operation is actually increasing the complexity to n square, because this is an order n operation. Now, when you perform like this is order n operation, which we are performing inside a loop of order n. So now because of this, it is n square. Okay. Understood? Okay. Now we have similar question. Let's see a few more questions. I'll come to how you can resolve this. There's a string builder that you can use. Let's solve one other easy question that you can count words in a given string. Is this done? You okay? This is an easy one. This is a very easy question on string. So basically, you're given a string, you have to just count the words. Good strings, okay, good strings. One test case is failing. So let's check. Okay. So what you have to do is you have to count the words. Now each word is separated by a space, right? So each word is containing some space separated words. You need to count the words in a string. So each word is separated by a single space. Okay. So every word is separated by a single space. You just need to count the number of spaces in here, right? If you just count the spaces, your number of words is going to be count plus space plus 1, right? So if I do I equals to 0, I less than n, I plus plus, and n is the, okay, there is one edge case, very funny edge case. So if you don't have any spaces over here, so that is having 0 words. Achha. If you have 0 spaces, that has 1 word, sorry. S dot char at I, if this is equals to space, then what we can do is we can simply increase our count, right? Sorry, if this is equals to space, we can simply increase our count. Okay. Now at the end, finally, whatever count we will get, we finally, let's say, increase our count, and whatever count we would get, right? The number of space is just count plus 1. Okay. So this is the total number of space we have. Now if I run this, so you see 5, right? Then now in case of this, we should be seeing 2 spaces, which is fine. Let's try to submit. Let's see if there is any issues, errors. Is there any edge case that I'm missing? Wrong answer. Okay. So it is 30, 20.
Sir.
30, yeah. So this one, right? This
Sir?
string. Yes.
Hello, sir.
Yeah,
Sir,
yeah.
the problem is, sir, if we put double space, your condition is not satisfied, sir.
So here it is telling that it is a
So,
space.
sir, you have to check the current and the next.
See. Yes, I know, but here it is telling some space separated word, right? So it is so words are generally 1 space separated. I'm assuming given the wording of the question, it is 1 space separated, right? But here, if in the example it has separated by using 2 spaces, then that can be the cause of this mismatch, right?
Yes, sir.
Actually, let's check.
Edge case after, it is edge case after a last word. Space, if we have space after last word.
Yeah, that is, I guess, the edge case. That is a valid. For example, in this scenario, so for example, let's say if I put 1 space in between over here and I take these as 2 spaces. Okay. If I try to get expected output, what is the expected output this compiler is telling in this situation to me is 5C. So in middle, okay, if we add more spaces in middle, it is not counting this space. It is actually skipping the space. Okay, if you have more spaces as well, so it is not counting the space. Now, what we can do in such a scenario is, see, if this is space, we are increasing our count, which is fine. Now, what else we need to do is, so while s dot char at I is equals to space, and s dot char at I plus 1, if this is double equals to space, right? Okay, not I and I plus 1, both of them are spaces. We just need to increase I. So this would ensure that these consecutive spaces are taken care of. Okay, let's try to check this. And if we have trailing spaces, for that we need to, so now we are getting fine, which is fine, right? If you have multiple spaces in between, now if you have multiple spaces in between of these words.
Hello, sir.
Yes.
Instead of this, sir, if we place this and after and part in this if part, then also the code is same, sir. So why is the need of while?
See, okay. So for example, if there are multiple spaces, we just need to skip all these spaces, right? We just need to skip all these spaces, and we just need to put one space for all space, right? So what we are doing is, okay. So we are trying to check if the current character that we are on is a space, and the next character is as well as space, right? If this is a space and the next character as well is a space, so we'll just try to skip this next character, because both those consecutive spaces will doesn't have any words in between, right? So again, same goes for the next two consecutive space. Yes.
Yes, sir. The skipping is also done in the if condition, sir. If we put this, the skipping is also done.
But in if condition, it will be done only once, right? If you have like more than this. So for example, if I just change it to if, it will not run it again and again, right? So for example, here, see, if I run this and I try to get that expected output, it is going to tell me that the expected output is on 5, right? Because we don't have any additional words. See, so it is telling expected output is 5, because if you have more consecutive space, it is skipping all of them. But if I run my code, I'm just skipping 2 of them. Okay, and then I'm going to I plus 1. Okay, see, now it's I'm seeing,
sir.
So I'm seeing 13, right? Because it is counting them. So you can do a else part, do it in if else checks, that's fine. But here it's written while it is not increasing your time complexity, right?
Okay.
Hello.
Yeah.
Sir, I have shared a simple solution. Can you take a look at it? I've
If
just
I plus 1
checked,
is okay, you are checked.
it
I
is
should be
working,
space, and it's that's fine. Yeah.
Even I told this, sir. Same thing.
Okay, that's fine.
No need of while, sir.
See, okay. So for example, let's say you, okay, so I'll talk about both the solutions. So I'll give you an idea. See, how do we evaluate solutions? So for evaluation solutions, we always consider we should have least amount of iteration, least number of lines of code, least amount of iterations. So we'll get the same. Here, how many iterations will we get? We'll just traverse the string once. We are not doing any like any place we are not going twice, right? Any two consecutive elements, we are not like this part of the string we are not going twice, right? We are just going it through once. I is the variable that we are increasing. Now, if you write it using a single if as well, that is also fine. Which you are telling is if we'll check this, if this is space and s dot char at I plus 1 should not be equals to space, right? So here also we are doing the same thing, right? If we don't write this in this loop and we just write it in this way, then also we are doing the same order and traversal, right? That's also fine. This is, I guess, looks simpler, easier to understand. I just derived the approach from the previous question. Okay, so this is fine. This is also fine. Okay, here at the end for the last character, you just need to handle it by n-1, and here handling it by n-1 would not break anything, because the last character needs to be a valid character. It does not need to be a space, right? So here handling that thing in the loop will not break anything. Similar not like the previous question. So in the previous question, if you put this n-1 over here instead of handling it in the while loop, you will see a erroneous result, because the last character you want to add it to the result. Here, if you don't need any last character, right? If it is space, you are anyways going to ignore it. If it is non-space, then it's fine, right? Then that is a word that we are counting, that we have already counted. Okay, so we checked I plus 1 is not a thing, we have counted it, done. Okay. So this was, I guess, the thing that we missed initially, and few of you also missed when you tried to do this. Okay, now it's fine. So that input you are seeing, where you are seeing this is string 29. So it is not a single space separated string, and it is multi-space separated. Now see, when you see inputs like this, I know this is very difficult. So is going through any test case, you won't be able to figure out what's the thing that went wrong, right? So ideal ways, if you think, right, what are the things that can go wrong, you can check for the input, expected output, and you can check whether your code is giving the same output or not. Okay, so is a doubt. So seeing the wrong result, we doubted that, okay, there might be scenarios like multiple spaces, consecutive spaces. In our case, we are counting simply spaces, so that is an error. So if there are multiple consecutive spaces, we don't need to count them. So this looks simple. If you are counting a space, that means we'll only do it if the next character is valid character. Okay. Ideally, A should not be counted, it's just a character, but here it is counted as a word, right? Okay. A is a word given the question, it's word. If there is like, there can be a different question where you don't need to count a single letter word like A or an or is, right? All these additional vowels, or what we call it as helping verbs as thing. So that's a different question that's not asked over here. Okay, understood, clear, done. Okay, anyone doubts on this solution? Fine. Yes, just okay. Okay. Oh, okay. So why n-1? Because I+1 is not going to be valid, right? If I is equals to n, then n-1, then this is not going to be valid. I+1, right? S dot caret n is not a valid index. Similar to A of n, we can't access it. Similarly, we can't access S dot caret n. So that's why we ran this loop till n-1. That was, we handle that scenario. Okay. Achha, any other doubts? Okay, good strings. That was one question that you all mentioned. Good strings. Panagram is very interesting question. How many of you did that panagram question? Usko kara hai kisi ne solve? Did anyone try how to do panagram? Anyone tried out panagrams? Done? Okay. Chalo, great. I'll talk about a little bit on that concept. Okay. Given a set of distinct characters, you are given and then it is called a good string if all the characters are present. Yes, this is the thing that this was the concept that I wanted to talk about. See. So this is a very good example to see, understand that ASCII wala concept that we saw earlier. I'll not start with string buffer today because I need this to discuss this concept. There is a lot of applications of this concept, so we need to know this. Okay. Okay. How many of you remember this ASCII concept? Remember? So every character is basically a number that is represented by the ASCII code. We have a valid number to it. Now, is there any application of this concept in case of string? It has actually, in fact, a lot of applications. Okay. So one question is this, the panagram question is also same. Okay, I'll give you the concept. Now you can try this using this concept and all the other questions will be solved. Okay. So see, let's say you're given a string. Okay. The string looks like this. Hello world. I am a coder. We are learning programming. Okay, so let's say this is like a string. I wrote a long string just to see we have a lot of characters in it. Okay, so we have like alphabets, we have a full stop, which is special character, right? Let's put something hyphen year 2023. So we have numbers as well. We have a special character hyphen as well. Okay, so a lot of things over here now. So now let's say there is a very simple question that is given to us is, can we count the occurrence of any given character in the string? So let's say we are given a string. We can find out its length using n. Okay, okay, this is fine. Now, can we count the occurrence of any given character in the string? We are given a character. Can we count the occurrence of it? So actually we can, right? This is a very easy question. There is no difficulty in this. We can simply go through the entire string and okay, sorry. What am I doing? We'll check if s dot caret I, and let's say the given character is ch. Okay, if this is equal, then we can simply increase our count. So our char ch is equals to, let's say, a, and our initial count we have taken is 0. They're a very easy question, right? We simply counted the characters, compared which all character match this character that we want to count, and we just printed this final count. Now, what I'm going to explain here is will give you some idea of actually how hashing actually looks like. Okay, so this is a brief example of it, not in very depth. You'll see hashing in detail. There is a lot to it, but this is a brief idea of how it would work. Now, see, if I just tweak the question a little bit, can we count the occurrence of each character in the string? Can we count the occurrence of each character in the string? Hashing means hash map. So hashing is a concept. Hash map is a data structure that is built using hashing. Okay. Okay. So now can we count each character? So let's think of the possible ways. Okay. So one way you can say is we can do things like we can check for first character. We'll check how many times H is present. Then we'll check for the second character, we'll count how many times E is present. Then we'll check for L, and then we'll count how many times L is present. Same goes for this character, and we'll print the count of each character. Looks good, almost fine, but okay, let's check. So I is equal to 0, I is less than n, I plus plus. So what we are proposing is we'll go to the entire string. J is equal to 0, j is less than n, j plus plus. Or not println. If s dot caret j, if this is double equals to s dot caret I, the character that we want to count, right? If this is equal, we'll increase our count, and we can take a count as 0 initially starting for everyone. Okay. And after we are done this, we'll print that the count of the character at j is caret j. The count of this particular character is count. Okay. Okay. So this was the order n when we were counting the count of any given character. Now we are counting the count of like all the characters. This is an n square logic, right? We like wrote a loop that is we are finding one character at a time. Okay, a count of character at I. We are taking each character, right? We are taking one character at a time. We're trying to find out its count, and then we are printing C. So when we saw H, we got okay, H is present only once. When we saw E, we got okay, E is present 6 times. When we got L, we saw L is present 4 times. When we saw another L, we again found out that L is present 4 times. O is present 4 times. Space is present 12 times. Okay. W is present 1 time. O is present 4 times, and so on. Okay. So there are 2-3 problems that I see over here. Firstly, we have an n square logic, which is the biggest problem. Okay, we are doing this in n square. Can we optimize it? Yes, we'll think of this. Okay. Now, when we are having L, we are printing it multiple times because we are repeating it. We are not printing it only one time. We are now the bigger problem is we are counting characters again and again, which should not be done, right? But we don't, since we are not storing it anywhere, we don't do anything. So we are like counting it again and again. We can solve it in one way, that what we can do is instead of doing this, what we can do is understood. So understood this solution. So we are picking one character, finding out its count in the string, printing it. Picking another character, finding out its count, printing it. Picking third character, finding out its count, printing it. Now this has pros, right? We are seeing duplicate outputs. L is getting printed again and again. Here also we see L print count is 2, L count is over here. We again see the L count, and so many times we would see L every time L is occurring. We are counting it again, which is problem, which is printing again. The logic is n square. We can optimize it. There is optimal logic in this. So this is like few of the problems that's there with this logic. Okay, understood the solution, understood this. Like password hashes, yes, passwords are also one form of hashing, right? So they are also encrypted, they are also hashes, right? Okay, so we'll talk about hashing. Don't worry, Himalaya. We'll talk about them. We'll have dedicated discussion on hashing as well. Okay, unwanted space complexity. We are not using any additional space. So for there is no additional space complexity. Okay. Now let's think of what else we can do. Okay. Acha. So this is fine. We started from here counting one character. Now we have like multiple. Contains have n square logic. Contains is just checking for one particular character. So this is order n. Contains is order n. Okay. There is a function that does this exact same thing, which it doesn't gives you the count. It gives you whether it contains yes or no. Okay. So if you want to check whether a character is present in a string or not, that is simply s dot contains. Now, can we implement this ourselves? If we just want to know whether a character is present, do you need this contains function actually? No. We can write this a single loop and check whether it is present, right? And the complexity of this is order n. Okay. Substring is n square. This is order n. How we calculate space complexity? Space complexity is calculated by the total amount of space we are using. So here we are just creating a single string, which is order n. So we're using order n space. That's it. Okay. Now space complexity, we so sometimes we also see it in this way. Let's say in order to perform an operation on two-dimensional array, right? So we need the 2D array, right? So 2D array is n square space, so that we know n square space is anyways there, right? What's the additional amount of space we are using, right? So what is the additional space complexity that we have added? So let's say it's n square and we are creating one more n square array or something. So that is the additional n square space that we are using. Okay. Okay, understood this? Like understood string, integer, this part, clear? Okay, so now let's look at the next part, which is this. So now let's say we want to calculate the characters. So instead of this, we can think a little bit smart. Okay, so we know that there is a given set of fixed characters. How many characters do we have? How many characters do we have? Any idea? So instead of we don't have actually 26 characters. No, the character is not 26. 26 characters nahi hai. Right? Is there only 26 characters over here? A capital H and small h, they are different, right? So we have like 52 alphabets itself. 52 to alphabets here. Then there are digits. Then there are special characters, right? So we have around 256 characters. So earlier it was 128 character set. Now I told you, right? It is a 256 character set, right? Yes, remember this thing. Now, instead of doing this, what you can do is just copy this, paste it, and you can check. So we are starting with the ASCII value 0, and we can convert this into char. Okay, we can convert this into char of I. Okay. So you are comparing the character I, ASCII, like whatever ASCII value 0 represents, and increasing its count. If finally, let's say we get the count is greater than 0, just to avoid that noise, if the count is greater than 0, then we print it. If the count is equal to 0, that means that character is not present. We don't print it. Okay. Now, if I run this, index out of string range. What did I do anywhere? Caret J, char I. Oh, so this one I've done. Okay. We can do char I. Now see, so now this looks clean, right? This looks very good as compared to what the output we were seeing previously, which had a lot of noise, where we were seeing duplicate L's count is getting printed 3 times, 4 times. There was no specific order that was getting followed. And the complexity was also n square, right? We are doing repeated calculation for any character. L was getting counted 4 times, 5 times. If let's say you have 1000 characters in a string and each character is just a, so you'll end up counting 1000 times, which is bad, right? So we don't need to do that. Here we have optimized it a little bit, right? We have optimized it. So what we have done is we have like assumed a character from the ASCII set. So we have altogether only 256 characters, right? So this character that is there in here can be any one of these 256 characters. Now what you have done is, let's say we picked one character from the set, and what we are doing is we are trying to count that character. Okay, so count that character, how many times that character is present in the string. And if we finally get the count as greater than 0, then we are printing it, right? If we just print that thing without checking this, what is going to happen? We are going to see a lot of characters having count as 0, and that is also going to get printed, right? So we again would see a lot of, so we saw so many outputs. These characters are not even valid. There are so many insignificant characters that we don't need, and we are printing them, right? So just to avoid it, we simply checked it. Okay, let's do this to avoid all such thing. And let's just check if the count is 0, then print that character. If the count is not greater than 0, we don't print it. Okay, understood? Yes. So we have space is getting printed 12 times. How can we remove space? Just check, right? If the character is equal to space, don't print it. If the count is greater than 0 and the char of I is not equal to space, you can check it, right? The char at I is not equal to space, then we print it. Otherwise, if it is equal to space, then we don't print it. Okay, so now see, space is not getting printed. Okay, but space is a valid character. We need to count it as well, right? So that is a valid character. Okay, understood this logic? What's the complexity of this one? What's the time complexity of this one? It's 256n. 256n, or we say it as order n, right? This is not n square, this is order n. 256 is the constant, right? So any constant into n, we say it as order n. No matter like it would be it would not work for 10 to the power 8, but it would work for 10 to the power 6, right? If you want to print in that order that I'll talk about that order. Lowercase, yes, for lowercase and uppercase, that also complexity is n, right? Yeah. So string functions doesn't have O1 complexity. All the string function don't have O1 complexity. Very few of them have O1. For example, caret is the one function that has O1. Apart from that, I don't think you have any O1 function. Is there any O1? Find like if you do contains, you do lowercase, uppercase, or if you do, let's say, so these are ON, right? Apart from that, okay, so majority of the operations are order n, right? There is really a O1 operation. Replace is O1, right? So yeah, okay. Now we can optimize. Okay. Now think what we can optimize. Okay. What else can we do? So this is the most optimized things we can get. Now, if we want to optimize beyond it, we need space, right? If we want to optimize it beyond this, we need space. So what we can do, like how can we optimize it? See, what's the operation that is happening over here? So we are taking a character. Okay, we are picking the character first. Let's say we are picking the character A. Okay. So capital H and small h are both different characters. It will tell their count differently. So for example, let's say we if it has both the characters, so I told you, right, capital and small alphabets are treated completely different. See, so here we have the count of capital H, I, W, Y, which is 1111. Now here you can see we have the count of do we have anything? So if you add Y or H or something, you will see their count differently, right? Let's say add HY over here. Okay, so if you run this, oh sorry, and I comment the code, yeah. So those are different characters, right? Same, it's just like that concept of capital and small characters are different. It is like case sensitive, so it will count them separately. See, Y's count is reflecting here, H count is reflecting here, right? And capital H, capital Y, their count is reflecting over here. Okay, so they are different. Okay, understood? Yes, no doubts? Yeah, sorry, I know there is some noise that is coming from the. Let me just do it on silent. Actually, I have our product launch today, right? So, so I told you already about loops, right? So you already know about Microsoft Loops. I showed you like that homepage. Now you can use it for yourself. That is launched today. That's live now. Because if you go to loop.microsoft.com, you can try it. Yeah, I'm sure you'll love it, right? You'll fall in love with it. And you'll never go back to things like writing things on Google Docs or Notion or something. Yes, Imal. If you have nested for loop, one inside another, if you write break statement inside inner for loop, break the inner for loop. Yes, it will only break the inner for loop. It doesn't break the outer for loop. So there is the inner loop cannot break the outer loops. Yes. Yes. Thanks, Nitesh. Now we have just started, right? That's the like first version of product that we have launched. We have like tons of things to do, right? Now we have just given one simple version. Now the expectations are going to be high, right? Sir, sir, there are labeled break as well. Labeled break means as in Joydeep, any labeled break, what does it mean? So I don't get what does labeled break mean. So break.
Hello, sir.
Yes, yes.
Sir, labeled break, what I'm trying to say is, suppose we are using two for loops. In the first for loop, if I use AA colon, and on the second, before the second for loop, if I use BB colon, and anywhere, if I state that break AA, then it will completely break from the loop, whether it is inner loop or outer loop.
Okay, got it. Basically, you are using same. So you are basically trying to tell the break which loop to break, right?
Yes, sir. Yes, sir.
Yes. Okay. So I guess there is a way to do it, but I don't think you'll ever require that kind of thing. It's I guess there is naming that you can do into loops as well. That's fine. Okay, I guess that's there, but I don't think we require it for now. That is one thing you will learn about that in concept of OOPS, right? That is again a part of OOPS where you will see about concept like overriding. So for example, you can have concept of overriding a operator. So basically you can change what this operator means altogether. Okay, so right now it is checking greater than, right? We can change what the definition of this greater to then to something else. We can use this greater than to perform addition. Okay, so that we can do. So we can name things. So similarly, basically we are giving name to the greater addition operation as greater than. So we can name our loops as well. Yeah. Okay. We'll discuss that now. Let's come back to this question and what else do you think we can optimize over here? I alone did not design. It's a very big team. It's like around 200 people. We are very small actually, I'll say, compared to the product that we have built. It is like 200 people, including everything, PM engineers, designers. If I talk about just engineers, we are not even 100 engineers in total. And how small that team is, you'll get an idea about like see any other site. That's like thousands of engineers working on that, right? And we are just even less than 100 engineers. We have built that complete thing. No, company always gives you that. So company always gives you company always gives you the laptop and anything you require to perform their work. You are not even allowed to join the use the office things on a personal device, right? You are only allowed to use it on office laptop. Just a second. I'm alone enough. No, there are bigger challenges to solve. Okay, so let's solve this challenge first. Okay, so we have this loop, we have two loops. Now, what is the thing that we need to optimize? How can we optimize it even further? Tell me, what's the problem over here? So I see one problem. So let's say we check A, if the character at I is pointing to a variable. What we are doing is we are going through the entire string and we check whether it is and the string has A or not. So we are traversing the string too many times. Can we reduce it? Now that can be reduced by use of memory, and look at here how I'm going to do it. See, so we can, instead of doing all this additional efforts, all this mehnat, what we'll do is let me copy. Okay, we have the string and we know the length. Okay, let's create a character array, and which is sorry. Okay, let's create an integer array, which is of size 256. Now, what does 256 represent? This is basically the character that's present in loop, right? This is basically the number of characters. This is the number of characters that is present in any string, right? This is the number of characters we have in string. Now, what I can do is I can simply traverse the string from 0 to n, okay, and we can try to store the count of each character in it. So basically, let's say we get the character using h.caret I. So what does this give me? This gives me the character of the string. Now, this character has an ASCII value associated with it. So all the numbers of h are going to have the ASCII value associated with it is same. So all the a is going to be 97, right? So if I write c, what does this mean? What does a of c means? What does a of this c mean? So if c is, let's say, a character a, what does a of c mean? So a at the index 97. So at the index 97, I just want to increase its count. Now look what it will do. So for a character A, we increase the count at index 97. For the character B, we'll increase the count at 98. For the index C, we'll increase the count at 99, and so on. Now, if I perform a operation which will go through the entire array, I++, and I check if, let's say, a of I is greater than 0, same check that I did earlier. If this is greater than 0, then let's print this. System.out.println, and we get a of I plus space, and we have, so okay, this is the count. What's the character? Character is I, and the count is a of I. Now if I run this, we would see this is counting the count of each characters, and this is printing it. Okay, see, we get the same output like earlier. Whatever output we were getting, we get the exact same output, exact same count, exact same result, right? So whatever output we are getting from here, we are getting the same output from here as well. Just if you look at this, this is giving you the same result. If I run this logic, just run it. See, the same result, exact same result we are getting over here. Let me just move this up. This belongs to here. Okay. If I do this, this is giving me whatever result this is giving me. The second logic is also giving me the same result. Now, what's the problem in this? So this was not, there was no problem. This was just where we had 256n. Here we have exactly order n. We don't have that 256n. And we also know the counts now. There we were counting it, we are not storing it, we are just printing it. But now we also remember the count of it, we have stored it. So if we want to use it, things like print all the characters having even count, we can print it. Print all the characters having odd count, print it. We can find out what's the frequency of each character in the string. We can do it, we can print it, right? Now, can we do it, Ryan? Yes, sure, we can do it. See, so what we are doing over here. So let's say we have created an array which is of 256 size, very large array. Okay. Why 256 size? Because there are 256 characters. Each index in this particular array is going to store the count of the character corresponding to that ASCII value. So for example, let's say this is index 0, 1, we have index 65, index 66, we have index 97, 98, so on. Okay, we have till 256. So what is this index going to store? This index is going to store the count of character with ASCII value 65. Which is that character? So A. So 65 is the ASCII value of A. So this index is going to store the count of character A. This index is going to store the count of character B. This index is going to store the count of small a. This index is going to store the count of small b, and so on. So basically, each index is going to store the count of the character which has the ASCII value as this index. Okay. Okay. Now let's look. So for here, what we are doing over here. So we are going through this entire, we are going through this entire string, okay? And we check. So let's say this is the string, very simple string. Let's say A, B, C, D, E, F. Okay. And let's say, okay, let's take this as A, B, A, B, B, A, B. Okay, let's say this is the string. So the first character that I get is A. Okay, first character s dot caret 0 is A. So we get this as capital A. Okay. Now what we do this, we just do A of C++. So character to integer is automatic implicit conversion. Remember, character to integer is an implicit conversion. 2 bytes to 4 bytes happens implicitly. The index of this has to be an integer, right? If you don't convert this explicitly, it will, if you don't use typecasting as well, it will implicitly convert itself into integer, which is equivalent to its ASCII value. Okay. So it will automatically convert it. So now what's the, so we have A will automatically convert it to ASCII value, which is 65. So we're doing A of 65 plus plus. Initially the array values are initialized with 0. So all of them are 0. We just change it to 1. Okay. Next character we are going to get B. So we are going to increase its count. We are going to now do it A of 66 with plus plus, which is B. So we're going to change it to 1. Next again we see a small a. So we do A of 97 plus plus, which we are going to increase 97 by 1. Then we see small b, we are increasing 98, it becomes 1. Next we see capital A. Now this time when we go to the index A of 66, capital B's index ASCII value is 66. Now this time when we go to A of 66 and do plus plus, we actually end up increasing this by 1. So now we actually counted how many characters do we have from here to here. We have 2 B's, right? So the capital B is present 2 times, we increased it by 2. Okay. Next again we'll see small a, it will increase it by 1, small b increase it by 1. Okay, so small a increase it by 1 becomes 2, small b increase it by 1, it becomes 2. Then understood how this count is working. Now for what this loop is doing, this is just printing. So if the count is greater than, so this is having count 0, 0, 0. We're not printing them, right? We're not printing all the characters which has count 0, similar to like earlier we were doing. So if it is greater than 0, we print that character. So now this is printing in the sorted fashion as well, because all the ASCII values are there in the sorted order, right? So in the array and the hash table class, if the time complexity, space complexity size is same. It is depends on what data type we are creating it. Yeah, but size wise it would be same. Yes, it would be same. If we use a hash table as well, it is going to be same. Yes. Size space is same, time wise it is same, but time array is like there the time O1 comes from a very lot of computation that goes on. Here O1 is very simple. Here the simplest idea of why we get O1 in array, because we are easily able to figure out that address. We are easily able to go to that address and read the value. In hash table there is a very different logic that plays out why we get that as O1. We'll talk about that, but not now. Yes. Okay. So this is the concept of you can use hashing. Now this is like super powerful. This looks like a very small concept, but this is super powerful. You can do a lot of things using this. Print anything related to counting of characters in array is just this. Now look at this question again from where we started this discussion. Take a good strings. So what is this question telling? You are given a string and you have to basically, you are given a list of strings. You have to figure out which strings are good strings. How many of these strings are good string? What is the definition of good string? That all the characters in this string should be part of this. Now, can you check that? Can you use the current concept that I explained to count this, check this? Strings are good, not. The same thing can be also used in panagram as well. So panagram is also a similar question. I guess panagram, yeah. Panagram is basically 2 words which are formed by using same characters. No, is it same? Panagram is a thing that contains every letter of the alphabet. Okay, how you can use the same concept to get this as well. If it contains every letter of the alphabet, you have this. So it does not necessarily need to be of 26 size. It can be greater than that. For example, see E is present multiple times. So it is greater than 26, but it is basically a panagram. Okay. This is, so yes, we call it we call it as hashing, but this is not actually hashing, right? This is not hashing, is completely different thing. We call it as, so we call it as Okay, we call it as count array. You can call it as hashing string, but this is not actually hashing. That is a different thing. So don't mix with it. Right? We programmers generally try to use mixed terms, but you don't need to do that in interviews. Okay, so that's why I'll avoid. I'll say don't use this thing as hashing. Okay. Now use this. I gave you the concept. I gave you hints. Now you have 2-3 questions that can be solved directly using this concept, which is panagram, which is good strings. I'm pointing you that these are the questions. Okay. Now try these questions out. Here, if you need only to create a 26 size array in this particular example, in case of panagram, but here there is one thing that this character can be capital as well. See, the first character is W is capital, but still it is a panagram string, right? So here you have to do one more check that if the character is capital W or small w, you still need to count it, right? That is a valid character. Understood? Yes, no, yes. Doubts? Hashing create some unique value for each character, right? Just like blockchain values, some unique hashing value. Yes, it is, but it is a complete concept. I can't explain it in a simple word. Think it like we have something and we are creating a new version of it, and both point to same thing. Take both mean same. Tell the approach of panagram. Okay, think. So let's think. So can we count whether okay? So one way you can do is you can check a capital A, is it present, B, is it present, C, is it present, D, is it present, and so on. Okay, this approach. So here we ran for 256 alphabets. Do we need to check for all 256? No, we just need to check for some 26 alphabets. What are those 26 alphabets? A to Z. Can you do it in this way? If the count of all the alphabets is greater than 0, then it's not panagram. You have to handle only the scenario of capital and small, right? So either it can be either 65 to 90 or 97 to 120. So you can check it for both, right? So you can check if that character is equals to let's say caret I or caret I plus 32. I plus, if you're running it for capital, you can check it in this way, right? If this is equals to this, or it is equals to like that the previous one. ये दोनों में से किसी एक के साथ भी equal है, then it's fine. Yes, ऐसा कुछ कर सकते हैं. ये तो easy है, right? I will expect this one you can think this part कि how will you ensure that you are checking for both capital and small. ठीक है? Because of capital small, you should not be seeing wrong error. Okay? This is one way where you are using 2 loops and doing it. You are not using any additional space. That's fine. It would get submitted. But you can also use an array. Now, how would that array work? How would that store it? You will get a complete ON, not 26n. You will get an ON. But how will you check that? That you can think of, figure out, right? That's the thing for you to think of, right? वही सोचना है यहाँ पे. ठीक है? Got some idea? Got the hints? ठीक है? Panagram. ठीक है? Good strings. ठीक है? So panagram, good strings. I guess there are few more questions which is on this. All substrings of a string. Now all substring of a string is easy, right? Is this not done? All subarrays of an array. I told you how to do that. Now, अच्छा यहाँ पे NZEC वाला error it might come. Otherwise, it should be fine. Okay, I'll explain string builder tomorrow in detail, so don't worry. We have a class actually for string builder, and that is, I guess, after sorting. Okay, so थोड़ा सा वो बीच में sorting and then there is string builder. I don't know why it is in that way, but yeah, in module it is in that way. Here also we have some question. Okay, lower to uppercase, reverse string words wise. Okay, now can you reverse a string? Now that's an interesting question. Can you reverse a string? If I give you a string, can you reverse it? Very easy thing, right? What easy है? There is no complicated. Run the loop in reverse. Okay, string reverse. Can you, if I give you a string and I tell you to find out a substring of it, can you do it? So let's say this is a string. Hello world. I am a coder. Okay. Can you find out any substring? Let's say this string world. Can you find this out? Yes. Okay. Now, if you can find out this substring, can you reverse this substring? Can you reverse a given substring? You can find out the substring, store it in another string, reverse that string. That's fine, right? You can do that. Now, this is the same question. Reverse the string word wise. String to integer array. Also reverse words in a string, right? Yeah, so you can reverse individual words. You can find the words, you can reverse those words, right? Now, can you not create a new string? So for example, you found the word is hello. Okay, first word you found was hello. You reverse this word. You got OLLEH. ठीक है, ये कर लिया हमने. Now, can you not create a new string which has OLLEH? ठीक है. Next time we'll find out the next word, which is world. ठीक है. You will reverse this word, so you'll get DLROW. Okay. And you will just add it to the result. So the result would become. Can you do this? And can you do it for all the words? Find out.
Sir, but in the question, we don't have to reverse the individual word. We have to just we have to append the hello at the end and coder at the front.
Acha, so you have to just basically you have to just don't do this operation. Okay, then that's even easier, right? Okay. So, acha, I'll give you one thing. Okay, एक छोटा सा मैं trick बताऊंगा. Then so this is a very famous interview question. I know we are already over time, but I'll take you just 5 minutes to explain this. Okay, so you'll be easily able to understand this. Difficult नहीं है. This is a very famous interview question. Okay, very often asked in input output question. This is very frequent input output question that you would see. So what is the output of this? What's the output of this when I am printing result? What it would be printing? Same as input, hello, right? No change. But we don't know n, right? So we'll not find out n. It doesn't do anything. It just is finding out the same string, right? No difference. But what if I do this? Not tell what it would print. So now it is actually reversing the word, right? So how is it reversing? So we are running the loop in the forward direction, but why the reverse is coming? So see, so the new character addition is happening at the start of the string. So firstly we get H, okay, so we add it. Next we get E, we add E to the start of this. Next we get L, we add L to the start of it. Next we again get L, we add L to the start of it. And finally we get O, we add O to the start of it. So we get O, right, which is the reverse of this. Now, can you use a similar concept to find out the words in reverse? So if you have two words, hello world, and let's say I am a coder, and you are getting words each word. So you got this word. So just add hello. This is your result. Can you add this word to the start of it? Yes, you can just add this new word here. Can you add this word to the start of it? Yes. Can you add this word to the start of it? Yes. Can you add this word to the start of it? Now is the string reversed? Now that's the biggest question. We are not running the loop in reverse, but how is it getting reversed? See, the addition is happening at the start. Now it is not happening at the end. Okay, if you add this character at the end, it would end up forming the same thing. So for example, if you don't do this and you do s.caret_i, if you add it at end, what is going to happen? You're firstly going to add H, then E, then L, and then O. New character always gets added to the end of the previous string. So when you were L and you got a new character, you added it to the end. When you were HEL and you got a new character, you added it to the end. Right? Now, instead of doing this, if you just do this, if you just move it to the start, what is going to happen? You are going to find out the reverse actually. Why? So first character you got as H, you added it. Next character when you're getting is E, what you're doing is you're adding that character to the start of this. You're not adding it to the end, you're adding it actually to the start of it. Next when you got L, you just added it to the start of it. right? Start of the result. You got L, you added to the start. You got O, you added to the start. Now this becomes reverse. The loop is not running in reverse, but the result that you are seeing is reverse of the string because you added the character in the reverse, right? You added the character and then the result. Understood? Yes, no? Okay, got it? Interesting. Okay. That's cool. Yes, it's very cool. Yeah, this is like one of the most asked interview questions, right? In interviews, you would see like this is written very casually, and it would be asked like, what's the output of this? At first glance, you might miss it, but if you have done it ever, right, use this, you'll never miss this. So whenever string concatenation happens, it might give you the reverse as well, depending on how you are doing. Strings is tricky, interesting. Yes, string is tricky. It is interesting. Now here on, like it will become very more interesting when you'll see string buffer and so on things. All the memory concepts that we have learned, it will be is wait list too long. I'm not sure about the waitlist. I just in a meeting, right, that was pinging me. So I was seeing the number of live user count, and it was like it has increased very significantly after the announcement. So it's not going to be too long that we have scaled that system, so you would be able to like access it. Just register it, you will be able to see that. And like you'll get that notification within 1 to 2 days, you'll get it. Okay, understood. So I've pasted today's notes in the chat. Please save it. Please copy the link. Otherwise, when the meeting ends, it would get erased. I'll share. You'll get it along with this. Okay, I have not shared the notes in a while now. I don't know if the recordings have that notes attached. They don't have, right? So okay, I will ensure that this gets attached today. Okay, so I'll do that today. Okay. Okay. Okay, now try to complete all the remaining questions on strings. Okay, there is one error, compiler error that you would get in a few string question, that is NZDC, which wherever you are doing string concatenation, the operations where there is like no string concatenation, there you won't see that issue. So okay, so that's fine. Try to if you get that compiler, we can't do anything. Try to use GDB to validate your code is correct. Okay. Now user count will higher it. It's already very high, right? I was seeing it. It's very high. So, thank you, everyone. Any doubts? Anything that you want me to answer? Anything? Any questions? Yeah, Himalaya. Okay, there was one question from Himalaya. Pascal's triangle. I forgot it, right? So let me cover that quickly. Himalaya, are you here? Shall we do that? Previous programming questions. Yes, we on the revision session we can utilize it in any way we want, right? We can utilize it to revise it, right? We have those revision sessions. We can utilize it to revise whatever topic. So revision session is basically you're driven by students, right? So if you have doubts, if you want revision, we'll do it. It's last week full of revision. So we have like this month specifically, we have like classes, we have days remaining. Actually, we don't get those many days. So we have 3 revision sessions that's planned. So okay, we don't have any more days, right? So by this weekend we'll complete syllabus. Then we just have 4 days left, right? 28, 29, 30, 31 on the month. And you probably have on first you would have your module test. So you have 4 days. Out of 4 days, we would have 3 revisions. We just would be having only one off. That is Friday, 31st, right? So 3 revision sessions as planned. Okay. Sorting, yes, sorting is there. Sorting is the last topic. Bash started on 5 March, but this month was 31st days, right? And we actually did 2 additional classes on 2 weekends, so that's 4 additional classes. So we were on time. If we finish early, that's fine. We get to complete 3 revisions. Last month it was crammed because we had only 28 days, and that was a problem. But this month it's better. No, it won't be on April 5. I don't think so. It's April 5. It would be on 1st of April. I think so. 1st or 2nd it would be, not on 5th. So it's generally the first Saturday that's lies around that range. So this month it's coincidentally lying on 1st of April. Okay. Just giving you a heads up, it would be around that itself, so that your next module also starts from the first Monday or Tuesday. Okay. Okay. Any more doubts? Anything? Okay, distinct palindroming. We'll do string questions, right? Whatever string questions are left, you have like doubts on that, we'll definitely do it. Today I gave you like new concepts that we did not cover yesterday. So I'm giving one more day. Try to solve string questions now, right? You know a little bit about how we can count characters, what is like, how can traverse it, substring, how can add, update, right? So now today do it. Which is your favorite? There is no favorite data structure, right? It completely depends on what I need, right? There cannot be a favorite data structure. You cannot have a favorite one, right? But map is something which I'd say I like a lot because it does a lot of optimizations to logic. Interview in module test, I'd say it would be not very difficult, easy to medium. Like I'd say easy to medium, not difficult, right? Difficult to nahi hoga. I don't expect very difficult, easy to medium hi hoga. If you've done ample amount of question, you understood the class concepts that we have discussed, so you should be easily able to clear it. No problems in that. Okay. Thank you, everyone. Please do solve the questions. We'll start from here, discuss tomorrow. We'll complete strings, and possibly if we want to start sorting, we'll do it. Okay. But we'll firstly spend a little bit more time on strings to complete it. Very much advice. Yes, if you feel like you're doing some question again, revision that you can do, right? That's fine. You can look through the code. You can try to practice similar questions for now. Right? Revision, you can do it at the end, but for now, like you can practice similar questions. Which question?
Hello, sir.
Yes.
एक बात बोलना चाहता हूँ सर
हाँ,
कि असाइनमेंट करते करते ऐसा टाइम हो जा रहा है, जिम क्वेश्चन करने का टाइम ही नहीं मिल रहा है.
I know that's like now the assignments are a little bit difficult and you require more time on each questions to solve it. That's fine, right? Gym is like you should at least complete assignments, and that additional time you get, you should do more gym. Gradually, as we do more questions on concepts, you will be getting more time on gym. Okay. So for example, like if we complete these assignments within 2-3 days, you would have 5 days complete new assignment questions, right? You won't get any new assignment questions, so we can just focus on gym, right? 5-6 days. So there will, even if we solve 10 questions each day on gym, so let's say I discuss 3-4 questions in the class at least, 5 if it is like easy ones, so we can you can solve 10 questions on the gym, right?
क्योंकि सर आपने कहा था ना सर कि 10 क्वेश्चन का टारगेट रखने को, तो सर 10 क्वेश्चन का टारगेट तो रख रहा हूँ सर, लेकिन असाइनमेंट में तो 10 हो जा रहा है और टाइम नहीं मिल रहा है.
ठीक है, अगर वो मीट हो रहा है तो फाइन है, राइट? असाइनमेंट से मीट हो, जिम से मीट हो, राइट? अभी के लिए वो टारगेट को 10 करना ही करना है. सो बाय द एंड ऑफ दिस मंथ की 300 हो जाए, ठीक है, हमें वो टारगेट रखना है. वो 300 असाइनमेंट क्वेश्चंस हैं और वो हो जा रहे हैं तो फाइन है. असाइनमेंट में नहीं है 300 क्वेश्चन, तो हमें जिम से करेंगे, ठीक है? Google interview, Facebook interview questions are on assignment. Yes, they are there in assignment. So all like interview curated questions are already on assignments. Okay. There are variations. Now that questions, like basic version of it would be definitely there. Now the interviewer might vary something on that question. Distinct triplets in the array list, which sums to X. Now, Asha, okay, array list question we'll discuss. I guess I have not discussed this, right? Okay, we'll discuss this one. Distinct triplets is hashing, but can we get it without hashing? Actually, we need to get the distinct ones as well, right? Okay, chalo, this is an interesting one. Then we need to get the distinct ones. We have to ensure that the triplets we are printing is distinct, not duplicate, and we don't have to use hashing as well. So, okay, we'll discuss this. Yes, we can validate the answer that we have stored. That we can do. Okay, I guess there is. There is way without hash map. Yes, there is way. So basically, you can store it in array list, and every time you find a new answer, you just try to go through the entire like result you have created till now and check whether the new result is present in it or not. Right? Not optimized, but yeah, would work. Medium easily हो जा रहा है, hard problem, so that's fine, right? वो तो होना चाहिए, right? Hard में problem भी नहीं आएगा तो then the questions are too easy, right? Hard level questions में तो problems आनी चाहिए, right? If I sit and start solving, I would also get problems in hard level questions, so that's fine, right? So problem तो आएंगे, that's fine, right? You are trying, you are solving it. That would take time. Gradually try to develop it, that logic. Okay, problems are there, that's fine. There is no problem in that. Okay, problems are there, that means you are trying, right? So good work, keep it up. Yes. मीडियम लेवल क्वेश्चंस में भी हाँ, सो टाइम लग रहा है, दैट्स फाइन, राइट. अगर सॉल्व नहीं हो रही है, फ्रेंड्स, वी हैव डिस्कस इट, राइट, so that's fine. There is concept that use there is question that use concept which might not have learned till now. So for example, that anagram and good string, right? If anyone figures that question concept out of themselves, that's fine, but that is a complete different concept altogether, right? To use an array, having like counting this characters and so on. Okay, so now try to complete the questions. We'll discuss it tomorrow. Thank you everyone. All the best. See you all tomorrow again. Bye bye. Good night.